Good evening to one and all here. All joined here for the 6-day online ATAL faculty development program on the topic design for manufacturing and advanced automation for industry 4.0. In this August occasion, I would like to invite Dr. P. Jamuna, Professor and Head Department of FDP, to deliver the welcome address.
Very good evening to one and all present here. It's my honor and privilege to deliver welcome address on this great occasion. Sri Manapura Nayagar Engineering College was established in the year 1999 with the approval of ACT, New Delhi, affiliated to Pondicherry University, Puducherry. The institution has 25 years of academic excellence and it has been accredited by NAAC with the name. All eligible UG and MBA, sorry for the inconvenience. The institution has 25 years of academic excellence and it has been accredited by NAAC with the A grade. And all eligible UG and MBA programs are accredited by NBA and also accredited by Tata Consultancy Services. It is the first self-financing institution in the country in India, established a community radio station called Nila FM 90.4 MHz to serve the community around the institution. Sri Manapura Nayagar Engineering College, Puducherry is proud to organize an ACT training and learning academy sponsored 6-day online faculty development program on the topic Design for Manufacturing and Advanced Automation for Industry 4.0 from 20th January to 25th January. In this August occasion, I would like to welcome Sri M. Dhanashekhran Sir, Chancellor, Takshashila University and esteemed Chairman and Managing Director for Sri Manapura Vinayagar Educational Trust. And I welcome our Secretary Sir, Dr. K. Narayanasamy, and our Treasurer, Sri B. Rajarajan Sir, and our Joint Secretary, Sri Architect S. Velayudu Sir, for this great occasion. Sir, all your vision, guidance, and expertise have been instrumental in shaping the pathway we step in and all success in our institution. I sincerely welcome you all. I welcome our Director and Principal, Dr. V.S.K. Venkatacharya Sir, for this great occasion. Your dynamic ideas are a source of inspiration and that propels us towards success. I welcome you, sir. And I welcome Dr. S. Dekmar, Controller of Examination, Dr. S. Anmalar, Dean Academics, Dr. A. Arivagar, Dean Academics, Dr. K. Vemurugan, Dean Research and Development, Dr. N.S.M. Kailasam, Placement Officer, Deans of various schools, HODs, and faculty members. All your significant contribution make this institution a nurturing and inspiring place for learning. I welcome you all for this wonderful occasion. I welcome all the participants from various institutions and organizations across India. This program, featuring eminent national and international experts, begins with a model-based design approach for manufacturing, advanced design automation techniques, integration with the industry 4.0 principles, exploration of upcoming trends in automation technology, and their potential impact in industries. We are fortunate to have with us a distinguished panel of experts who bring a wealth of knowledge and hands-on experience. Their insights will undoubtedly provide valuable takeaways and actionable knowledge for all of us. As we embark on this journey, over the course of the program, I encourage all of you to actively engage, share your perspectives, and take full advantage of this platform for knowledge sharing. Together, let us build a collaborative environment to foster innovation and excellence. Once again, I warmly welcome you all, and I look forward to an enriching and productive online academic program. Thank you. Let us begin this exciting endeavor. Thank you for the opportunity. Thank you.
Next, I would like to invite our beloved Dean Academics, Dr. S. Angumalar Madam, to deliver the presidential address.
Good evening, esteemed dignitaries, respected resource persons, colleagues, and dear participants. It gives me immense pleasure to welcome you all to the ACT Training and Learning Academy sponsored 6-day online faculty development program on the topic Design for Manufacturing and Advanced Automation for Industry 4.0 which is going to be held from 2025 to 2025. As we join here today, we embrace an exciting opportunity to delve into the transformative paradigm shaping the future of industry and academia alike. The theme of this FDP is not just timely but vital. The fourth industrial revolution, commonly known as Industry 4.0, is revolutionizing the global industrial landscape. With technologies like artificial intelligence, machine learning, IoT, advanced robotics, and additive manufacturing, we are witnessing a shift from traditional practices to smarter, interconnected, and more efficient systems. This transformation has profound implications for manufacturing, where design for manufacturing plays a critical role. By integrating design principles with manufacturing capabilities, DFM not only reduces cost and time to market, but also ensures higher product quality and sustainability. Combined with advanced automation, it provides a foundation for creating innovative solutions and meet the demands of a rapidly evolving market. In this context, our role as educators and researchers become paramount. We are not just preparing the workforce of tomorrow, we are shaping the minds that will lead this revolution. It is imperative that we keep pace with these advancements, continuously updating our knowledge and skills to align with industry demands. The 6-day FTP therefore serves as a bridge between cutting-edge industrial practices and academic excellence. Over the next few days, you will have the privilege to engage with eminent speakers from IIST, IIT, NIT, and reputed industrial organizations. Learn from their expertise and explore practical insights into the technologies driving Industry 4.0. I encourage you all to participate actively, ask questions, share your perspectives, and make the most of this valuable learning experience. I would also like to take this opportunity to appreciate the organizing committee for the dedicated efforts in conceptualizing and executing this program. Your hard work and vision have made this platform possible. Our heartfelt thanks to the resource persons whose contributions will undoubtedly enrich our understanding and knowledge. And finally, to all participants, your enthusiasm and commitment are greatly needed for such initiatives to be successful. Once again, I extend my warmest welcome to you all. I wish this FTP be a great success and hope it proves to be an enlightening and transformative experience for everyone involved. Thank you, and I look forward to the engaging discussions ahead. Thank you all.
Thank you, ma'am. Thank you for your blessing. Dear sir, madam, as per the schedule, the first session is model-based design approach for manufacturing by Sri Gautam Rajmohan, Technical Manager, MATLAB, ARK Info Solution Private Limited, Chennai. So, in this occasion, I would like to invite Mr. K. Tangaraj, Assistant Professor, Department of Triple to introduce our speaker.
Good evening, everyone. It is my privilege to introduce our resource speaker, Mr. Gautam Rajmohan, Technical Manager, MATLAB, ARK Info Solution Private Limited, Chennai. Completed BEEC from Sri Nandanam College of Engineering and Technology and ME Embedded System from SNS College of Engineering. Started working as Senior Research Fellow and successfully completed 2 BSc project titled Intelligent System for Greenhouse Environment, valued 25 lakhs, and Smart Water Supply and Distribution System, valued 2 crores. Worked in EV startup as R&D, embedded developer for programming and testing PMSM motors. Work experience in embedded control including Arduino, NodeMCU, VASP Mode, Raspberry Pi, TI, MindMotion, ARM and PIC controller. Work experience in software tools including MATLAB, LabVIEW, Google Firebase, ThinkSpeak, MIT App Inventor. Chaired as BOS member for SNS College of Engineering and support faculties of various institutions for setting up IoT and embedded lab. Sir consulted many Harvard projects for UG and PG students in Coimbatore region and published several articles in SEA and Scopus journals. Currently working as Technical Manager, MATLAB, ARK Info Solution Private Limited, Chennai, handling academic technical training in mathematics, IoT and low-cost hardware, ML and DL with MATLAB software. We are honored to have Mr. Gautam Rajmohan with us today to share valuable insights and expertise that will enhance our knowledge and skills. Let's give a warm welcome to Mr. Gautam Rajmohan. Welcome, Mr. Now I hand over the session to our beloved speaker, Mr. Gautam Rajmohan, sir.
Thank you. Thank you. Hope I am hope I am audible to you.
Yes, sir.
Yes, sir.
Yeah. Thank you. Thank you so much. First of all, I'd like to congratulate Sri Manakula in Vinayagar Engineering College management, the principal, dean, as well as the department organizing, including Dr. Sivaraj sir, to making this event ATAL FDP on design for manufacturing and advanced automation for Industry 4.0. So to begin with, so this will be the topic which I have chosen today. The model-based design for manufacturing will be the right one to start with. Yes, let me share my slide. It's here. Hope, yeah, hope my screen is visible.
Yes, sir.
Thank you so much. Thank you for confirming it. Yes. So to begin with, model-based design, and this will be a perfect choice to give a kickstart for this ATAL FDP title, the Design for Manufacturing and Advanced Automation for Industry 4.0. Why? Because like manufacturing, as we start the industrial revolution, this manufacturing coming into the picture, and this has been taken for a very long journey to reach that automation, and now we are heading up with a very futuristic technology called as AI that will take up this industrial revolution into a new perspective. Okay, where that in that at the time of start, where the machine has taken the too much of load to make that industrialization to happen. But now, beyond that, the machine now no more controlled by the human. It might be controlled by the AI, that algorithms which we have developed, right? So to start with, this topic will be much suitable to give a kickstart for this Industry 4.0. Okay. To begin with, this is Gautam Rajamohan, Technical Manager working for ARK Info Solution at Chennai, as Sir was stated in the intro note. Okay, let us begin the session with few insight on industrialization. As Dean Ma'am Andamala Ma'am rightly stated, industrialization is very, very important. Okay, so without industrialization, and we cannot never ever dream of reaching this much height in the technology and in the perspective of engineering. Okay, so what is that actually happened? If you take the history, industrialization is not only a thing that is required only for making of the mass production or something else. It is also penetrated in other domains as well. Okay, so automation is that first perspective in the industrialization to give a benchmark. Okay, where the machine could perform the repetitive task. So human has identified, despite of using human for many much more hours to complete a production, they have come up with machines. Why a machine could not perform some repetitive task more efficiently than human? This has laid a foundation for the future automation actually. Just by replacing the human work wherever the human may feel that tired or may feel they are burdened up, that can be replaced by the machine by doing a repetitive task. And slowly it has been moved to an industry and giving our new way to open a new concept called as automation. And nowadays it is slowly evolved into the next phase of modern robotics and AI systems. Okay, so this enables us to make a massive production in a short time, and with having the efficient work for the human workforce, which who are laid in the industries. Okay, and actually in the history, if you look up for this automation, where it is actually started and where it is actually lined up, we everyone know one particular phenomenon person called as Henry Ford. So who actually set up the assembly line in 1930s actually. So he is a key person who started this massive production and assembly line type of today. Wherever we go for mass production, there we can see this assembly line will be set up, right? So he will be the key person for setting up such massive production in 1913 itself. Okay, this assembly line is an automation done by this Henry, who is actually a game changer, we can say, which make a drastic improvement in the production, which reduce the production time and the cost that is involved. So which most of the manufacturers are looking the production time and the cost cutting measures. Okay, this is the two key thing for any manufacturing, many manufacturing industry they look for. Okay, so the pointer, the person who set this vision will be the Henry Ford, who is the game changer and set the mass production and assembly line technology, now which we call that as an automation. Okay, and now that is more into a little bit evolved into a next perspective with robotics and AI. Okay, so this technique spread across industries and transforming the goods were produced on large scale. The principle of mass production and assembly line technology are still used today in the modern factories with a little bit involvement of robotics and as well and AI as well. Okay, so okay, it is whether only the industrialization happened only in the perspective of hardwares or the on the perspective of mechanical. No, it is also happened. It is also reached in other domains as well, like communications. They have started from telegraph. Now, after then, they moved to radios. Now, you people are already witnessing 5G, 6G, all this technology. Okay, and this also penetrated in the field of electrical technology, and this given a way for us to have the precision machinery. Okay, one of the key technologies that happened. So we people are using several tools, and we nowadays witnessing several surgeries are done by robotics. So these are come under precision things, and this precision is possible, and this precision give us a way to do the high quality things what human beings cannot be able to done, that can be done with the field of robotics. This precision has been set up, and the materials which we are using right now, that also has been done by using, we can say that these are the few major things that we achieved through this industrialization. And now we are witnessing advanced electronics, since everyone we uses the mobile communications, right? So these are some of the advancement done in electricization, and this we state as a rise of electronics, right? So from the early innovations from the telecommunication, from now we have used the mobile on the go. Okay, so all these things has brought us into an factor that where the industrialization has set us to touch all the new technologies what we are using today. So rapid industrialization, yes, we need to make the development in a faster way. So we have many competitors there in the industry. So if you take a mobile industry as well, we have lot of mobile manufacturers are there. And the time to market is very, very important, as Anbumara ma'am stated, right? Time to market. So whoever pitch in first, he will be noted as a leader in that particular market. Okay. So that time to market is very, very important, and the fast phase of development is very important for the economical growth of the country as well. Okay. So this rapidization of the industrialization is not only support or not only making the competitive world in the manufacturing industry, but also this help us the economy to grow in a fast pace. Okay, and the technological innovation and the technological often leads the technology advancement, and the widespread adoption of automation, machine learning, and artificial industry in the used in the industry that help us to achieve several more new things in the technological perspective. And the rapid industrialization also leads to a large scale shift in the populations from rural area to urban, and seeking for setup of the factories and industries in the urbanization as well. So it is not only limited. So whatever that happened in industrialization is not only limited in the industry, but it is also help us to transform our life from economical as well as our own human life conditions as well. Okay, yes, and we need several supports for the capital investment and infrastructures. These are required for us because without infrastructure we cannot do a lot of things. But as of our India, we are very strongly moving in all the domains, and we are ready to witness a lot more advancement in our country that is going to happen in next 5 years. Okay, and yes, we are making a global platform market where we are ready to import and export our goods in our country. Okay, So why this particular thing I want to speak today as of industrialization? Because the topic which we have chosen, the design for manufacturing and advanced automation for industry 4.0, actually it is started from this particular concept called as industrialization. Okay, yes. So what is the challenges that we have today? Due to several factors, we have some challenges with us, right? So resources, yes, finding appropriate technical skilled persons for the resources as well as the material things. Yes, there are some resource depreciations are there, and time to market is very very important, and technological updation with the people who are there they are working with us, and testing and validation is very very important. Since nowadays, even nowadays, we are finding some aftermarket product are getting defectives, and reusability is very very important, uh, because our time whichever we invest it to be utilized in a very wise condition, and that to be made very rapid in a rapid way, then only we can always showcase and we will be the market leader. Okay, yes, that is very very important. So this industry, entire industrialization, manufacturing, everything, actually now what is happening, how the rapidizations are possible, thus that can be picturized which one concept called as model based design. Hope we have dived into our topic what we have given. So industrialization, the rapidization is possible, and most of the people might not aware this particular concept called as model based design. Okay, so today we have an opportunity to discuss this particular concept called as model based design, and most of you, few of you have come across this particular concept in an industry perspective. But today we will take this same concept in several other perspectives to see how this model-based design concept is actually working in industry, how this can help us in doing uh, time to market, reaching the product time to market, and making a reusability with the particular model which we have designed at the initial, and how we can make verification and validation in a very short note, and what is the user success story who has adopted this particular model based design concept. Okay, so model based design concept is actually, it is a methodology. It is not a new thing, actually it is a methodology. So we have several stages here actually. So the stages which as you seen in the screen: model creation, simulation and analysis, automatic code generation, research and development, verification and validation, deployment and maintenance. So these are some of the common stages actually. If you check with the products, manufacturing products, these are some of the common stages we can actually, you can see these as stages. First, let us see what is this model creation. Okay, so usually I think most of you people has come across with a concept called as prototyping. Usually, we people from academic background, we know about, we have done several projects, several models. When we also insist the student to do some prototype. Okay, please do the prototype so that you can understand how the actual things is, and you can get know about the things is how by each particular model is working. What is the range? What is the operation? And how the functions are happening. Everything you can do. So that we will suggest people to go with prototype. Correct? Yes. So that is actually there for that model creation. So model creation is that engineering built this model, actually a prototype will be built that represent the behavior and characteristics of the system, so that we can experience the functionality and also understand how each particular modules work, and what is the correlations with the hardware, software, or how the hardware is responding, hardware or the how the particular machine is responding to that particular input. Okay, so this model can be ranged from the simple diagram. If your model is a simple model, you can actually go with the flow chart, or you can prepare a simple block diagrams, and you can actually model it. So suppose if if you are end up with the complex systems like rocket or automation systems where includes a lot of machineries to be involved, or a robotic manufacturing unit, if such type of things is, yes, please go for the prototyping. Okay, if such things are there, yes, you can go one more step and do complex simulations and mathematical based evaluation also you can perform. So that's there in your model creation. And the second step, once your model is ready, somewhere you built your model, either that may be in the software or you have developed a prototype. Okay, please try to make a simulation out of it. That will be very important. There are several simulation softwares are available for us today, and you can from starting from the simple floor plan to that AI-based controller robotic automations. We have simulation environments. We can build those simulation environment, and we can test it. Why we recommend people to go with the simulation environment? Actually, you can test with several different scenarios. So we cannot like always build a model whenever we building a model from the scratch. It is always not that once we build a model we can go directly for testing. Okay, so please please do build the model and do go for the simulation. That is very important. Test under different conditions. So which are the conditions that might require for you to test? Please test those conditions. That will allow us to go and check for the early detection of errors. We can predict some errors. We can detect some errors, and we can whenever we perform testing, several new learnings will be there for us, and we can able to modify in the prototype level itself. Okay, so that will help us to ensure that our time to market and our production will not get failure in the aftermarket. Okay, yes. So this will help us to make early detection of errors and optimize the design for physical prototyping, which we are actually building. Okay, so we can actually detect the errors and make some optimization because the entire model which you want to develop, actually that prototype was built in the simulation platform. That particular model you can test for several different scenarios and understand what are the errors that is coming up, whether our design is okay, whether our model is giving the proper response for our input, and whether the algorithm which we assume that is running perfectly with the hardware or with the machine which we are trying or which we are going to install in our floor plan. And we need to find an optimizing of the design that is also possible. Okay, so instead of going for directly landing up into a physical prototype, yes, there are several modeling platforms are available for us to make simulation and analysis and make our model error free and make a design in an optimized way. And the third step, once your model is ready, you have developed and tested for that is simulated for different conditions, and you have optimized. So what is the next step? So we need to go for the actual version, the real version of the model. Okay, for example, if you are setting in a uh, robotic floor for an industry, where your robotic model is going to make for that. Let us take it is a car manufacturing industry. You have several robots are there for all painting, setting up machines, and setting entire your car will be taken care by the robotic platform. Okay, so let us take this is our particular concept we are going to work. So our first thing, we have developed this floor plan in a software, and we have tried out our robotic model, and each segment, each stage of the robotic work has been tested with our simulation platform. So now what is the next challenge? We need to develop code or the program or the algorithm for that particular robotic model. Since because it is going to, as of automation, we know that this particular robotic models, this particular robotic industrial arms are going to repeat the task in such a way so that it will try to complete the work which is assigned to that particular robotic stages. Okay. So once your simulation is over, the next step you need to move for the code generation, the programming part. Okay. So there are several softwares are available with us where we can use those softwares for automatic code generation. So one significant advantage of this MBD software is actually model-based design software. They have the ability to create this automated code. So once you complete your simulation and work make that analysis, that miniature that if it is working fine, yes, you have an automatic code generation in this model-based design tools, where that particular automatically generated codes can be taken from that simulation platform and this will help you to make the rapidization actually. So we don't want separate time, or we don't need separate software team need to be sit and work along with that uh, uh, robotic, that hardware team, to ensure that everything was going in hand and everything was working fine. Actually, it is not required. This MBD tool will help you. Based on your design, you can actually generate the code, and these are automatically, these codes are based on the different conditional behavior analysis, and your algorithms can be extracted and that can be deployed with your automatic code generation tool. And this reduces actually the errors introduced in that during the manual coding. Since your entire machine behavior, it is understood by the MBD tools, model-based design tools. So your what are the errors that are involved during manual coding that can be actually, that will be eradicated when you are going for this automatic code generations. And one more thing, what we are achieve, the consistency actually. The consistency between the design and implementation phase will be also achieved by when you're using this automatic code generation. So in this 3 step, what we have done, so you have developed a model based on your requirement. Since we are discussing about a car manufacturing robotic unit, so this robotic, each stage of robotics characterizations has been modeled, and this characterization model will also include complex simulation and mathematical steps, evaluations, and that can be modeled with the MBD tool, model-based design tools, and we have to check with the different condition. Why we need to check? We need to identify the errors early so that we will not lose our value, lose our capitals in doing a wrong design. And second thing, you can optimize for the physical prototype. And we MBD tools have a facility called as automated code generation. This will help us based on the modeling feature and perspective. We have already made several trial under simulation. This automatic code generation will help us to deploy the code with the real version, that is, which is the robotic model that we are going to install. Okay. And third one is very, very important, research and development. Okay, once your model, yes, now your model prototyping is ready, your simulation is working fine, your automated code generation tool gives you automated code that we can be introduced with less errors, or we can say like error free, which happened during your manual coding, and we have improved the consistency between the design and implementation. Everything was achieved. Now it has been moved to and deployed. So what is the next thing? We need to make research and development. There are many factors. The industry is fast growing, and every 3 months we have a new product in the communication sector. Every 6 months we have a new product in the automation sector, and every year we are stepping into a new gen where the old version is no more compatible with the new one. That is, it is far more faster and better performing than the old one, right? So research and development is very, very important. So how actually it is achieved with this MBD tool? So MBD tool help us, the model-based design tools help us for the iterative development of the process. Okay, you can slowly start working with this tool because MBD tool help us you to work on each phase separately. That is the special thing. We will call this as V workflow. So if you have time, please identify what is this V workflow. Maybe this model-based design tool support one particular workflow called as V workflow. This V workflow help us to work on each stages, because whatever we are doing, whatever we are developing in the model, that particular model was done with our simulation tools. So we have an option to work on each stage. Okay, so that research and development can be happened with this MBD tool, and we can continuously refine based on the requirement of the result. Okay, we can set, tune and tweak and adjust, and everything can be performed in this model-based design, and continuous refinement can be done. And based on the stakeholders' feedback, we can work on. Suppose maybe like next year there may be an interest from that customer that everyone want an interactive car interactive car software, along with whatever the things is that are having based on your everyday lifestyle. The car should be like it should be featured with your daily routine activity, so that whenever you leave office, the AC should be automatically done. Whenever you started from your home, your tracking should be automatically given to your homemates. Whenever you are in trouble, whenever you need some emergency, it should be automatically notified. So there may be some customer perspective or some stakeholder perspective can be there. So based on that, we can actually rework on each stages. Actually, that can be also be done. Okay. So this can be done with that MBT tool. In the future style, we can discuss what is there actually happen. And verification and validation very important in any industry, because now also we are facing several defects in the aftermarkets. So verification and validation very important. So model based design will help you actually to validate against each, from the requirement phase to the testing. Each phase we can actually validate whether the stuff which we have developed in the model based environment is working fine or what. Okay. And deployment and maintenance, yes. Once validation is done, model can be deployed to the control systems, and as we discussing on the car manufacturing unit, we can actually deploy the codes once the MBD, once your MBD tool is okay, once you have developed your platform, everything is done. Once you have tested and validated, verified, you don't need one more separate team to work for the software. Not required actually. You can actually deploy the code directly from your model-based design tool, and you can connect it with your robotic model connected, and you can directly perform. And since it is based out of a control automation systems are based on the background of control systems, those control system can be automatically monitored with this model-based design tools. How it is actually working, what is the actual signal has been transmitted, what is the response you will get, everything you can actually uh, all the performance and the updation of the model that will be reflected to your model based system. So that will help us to understand how the performance of the system, how the performance is, how the system is performance, and understand how the system is actually working. Okay. And the overall model based design promotes us, okay, by adoption of this methodology, this model based design, promote us efficiency, reliability, and flexibility. Okay, so this three is very important. Whenever we look for in the mass production, as the stakeholder perspective, they will look for these three things: efficiency, reliability, and flexibility. So these three can be achieved with this model-based design. And in the development of this complex system, by leveraging the power of abstraction, simulation, and automated code generation. Okay. So these three things can be directly achieved when you are adopting this model-based design. Okay. So coming to the next slide. So as we stating that model-based design for for a long period. Okay, what is this model-based design tool actually you are talking about? So which particular tool you are concerning about? Actually, we have one such tool. There are several other tools are there in the market actually. Many tools are there in the market supporting this model-based, like LabVIEW, SolidWorks. They are supporting this model-based design. We have one tool in MathWorks called as Simulink actually. So MATLAB is we have three products actually from the house of MathWorks. I think most of you know this. We have three products. The first product we will call this MATLAB. Second one is Simulink, and third one is SimScap. So out of three, Simulink and SimScap will give you that flavor of this model-based design. Okay, and MATLAB, you know, this is a traditional software which has been there in the industry, used by the industry for more than 40 years. And all the computation, wherever you need some mathematical support, wherever you need to do the complex mathematical analysis, development of algorithm, ranging from simple to AI, we can do with this MATLAB software. And Simulink give you a flavor of a block-based environment. So everything will be in Simulink. Most of you have a handful of experience with this particular software called Simulink. So here you have the blocks. So everything will be available as blocks. Just pick and plug these blocks and connect this block, set these parameters, Okay, and you can play with the parameters. Once you are ready, you can simulate. Once your simulation is done, once you feel whatever you are done with the simulation is okay, you can move for the next stage. You can go for one step ahead and make some hardware settings. And MATLAB support almost all the popular hardware, whatever there in the industry. Okay, so that is the special of this particular software. Almost all the hardware you can actually connect with this software. So connect it, and just 2 to 3 more clicks, you can actually transfer the code from Simulink to your hardware, and you can see the response behavior, everything, and you can make some analysis over your signal and data back to Simulink. That is also possible, and you can track everything from the software itself. So Simulink, it's no more an simulation software. We can actually connect all the hardwares, control systems, measurements instrument with this software. And nowadays, it started bundling this software start bundling with other hardware devices as well for making it better understanding and acquiring signals and the data from the external machines. Okay, and we have SimScape, one of our third tool that will help you to do the realistic world. We will call this as a real world, real time environmental analysis. And you people has witnessed the launch of Chandrayaan, right? SimScape is one such tool. So actually, what they are showing in from the control panel, which they are showing, it is actually not the live image. Actually, that is one of our flagship product called as SimScape. So what are the things you have seen in the screen? That is actually that model has been built in SimScape. So all the aerospace mission and all the aerospace agencies starting from ISRO, NASA, and from Russian aerospace, they are using this software called as SimScape. So 3 flagship product, and to get that flavor of model-based design, Simulink and SimScape will help you to do this model-based design. Okay. So our software actually, just to give a brief, this software, those who don't know about our software, this software has been used for almost all the pioneering places, all the pioneering industry, wherever we get the updates in a very short note, or where the rapidization is happening, they are using our products for their day-to-day R&Ds, as well as they help up in wherever required this extensive mathematical capabilities. They are using our software, and we are no more limited to like simulation. We can connect hardwares, and we are now, and the recent version 2025A has been released, and you can actually use Python as well with this software. That is possible. So just to give a heads up, MATLAB, this particular model-based design tool, Simulink and SimScape, it is not like how many people they are using. Like all the top 10 auto manufacturers, they are using this software, and top 10 aerospace companies they are using, and 3 out of top 5 internet companies they are using. So just to say that this software will help. It is helping more than 90,000 business, government, and university around the world. They are using our softwares. Okay. Yes. So what is model-based design anyway? So just to understand, let us go to conventional method. So from now onwards, we are a little bit moving in a very focused way. We are taking one such example from industry perspective. We have taken EV cars. Okay, and from here we are good to go with how this model-based design actually this adoption, how it will help us, and what are the problem that is happening in the conventional design conventional design process, and what will how they are actually using this conventional design process, and what are the problems that are required, and what are the different stages different problems are required. If they are failed, what will be the problem, and how much time it will involve, and how much capital will be the capital requirement will be done, and how much performance issues are happened, and the checklist and the hard work of the people, everything we are going to discuss. So we are taking some design of an EV car. Okay, so let us discuss on the first conventional design process. Okay, So conventional design process, everyone knows. We will start with that requirements. Okay, correct. So what is the actual requirement? What is our product or what is our outcome? What is the thing we are actually aim in our mind? Okay, so here to our today discussion, we have taken this EV car. So we need to check with. So now we are going to design a EV car. So what is that requirement actually? What are the things that are required for us to design a EV car? Okay. So next step, we need to identify in the component level what are the things required mechanically, electrically, and what is the control system, and how your embedded softwares are there, how the interaction going to happen, what is your communication mode, and what is the design parameters you have taken, and how your hardware software play should be there. So everything we need to identify that we call as that we do in the requirement phase. The second level will be the component design, and the third level we are go for system integration. Okay, we need to going to fuse this hardware and software and going to make a system out of it that we call it integrated system that going to work with your hardware based from your support from your command from your hardware, your command from your software, your hardware going to work. So we make an integrated system, and finally we will test it. So this is the conventional design process. We need to identify the requirement and go with the component level designing. Okay, and we do system integration, hardware software integration, and we go for testing. So this is our conventional design process for any type of let us say like any type of automobile manufacturing. So today we are taking a scenario of EV car, so which is very trending now, right? So what happened? So what is the problem happens? Here you can see. Okay, so each stage we have a different problem. Okay, so if you take in the requirement phase, okay, so the analysis on that requirement, okay, whether whatever the things is we have make a choice, whether it is right, whether the component whatever we have chosen, it is right, and integrated with the design, whether the component what we have think and the design what we have made, whether everything is going in hand to make that perfect system out of it, and difficult to manage the changes. So if you there and most of the people who are working in project they know about this. If you change a particular component and every other component that need to be support the change of the component, that is very very important. Or else the entire system need to be keep on changing until you identify a perfect system. Okay, so requirement is very very important than the testing. I can say like that. One, if you find a proper requirement, if your design and the requirement are perfect, and the worry about testing and the difficulty what we face in testing will be like we can say like it is very less. So identifying the proper component, going with your design, and finding out that the design and the component is good, that the fit with the design and the component should be ideal, so that your problem in the testing will be reduced massively. Okay, so that is the first thing you need to look for. Your design and requirements are working better. Okay. The second step, as usual, we need to do the prototype. What is the problem? If you take for an EV car, the prototyping time itself very costly. Why? Because the component what we are using for the EV cars itself very high cost. The high efficiency motor, your high efficiency PMSM motor, permanent magnet synchronous motor, is very costly. And designing that particular motor is involved too much technical people to make a perfect design out of it. Secondly, batteries. Since we are using lithium batteries, they're too costly. And affordability for testing itself for a small, if you testing for a startup company to make this assembly to make and testing for this EV car in a full functional mode required minimum of 30 to 50 lakhs, including all the test cases and test benches. So affordability is very very important. So it is difficult to make an expensive thing out of it. Okay. The second thing, rapid iteration. Since these components are very costly and what we are connecting, what we are testing out of it, making physical prototype, and the rapidness cannot be done at the initial phase. That is very, very difficult one. And no system level testing we can be performed at the physical prototyping. Right? So these are some issues we are facing when we are going for the physical prototype. Manual coding, very, very difficult since I have faced this issue when I was working as an EV engineer. So at the type of manual testing, we should be very, very careful since we are going to perform on the direct prototype which they have already designed. If something goes wrong, then everybody need to rework. Okay, and we need to check our code several times before before connecting with that real-time hardware. So we need a space to check where you will check actually whether your code is working. Some platform should be required to you where you can actually build the model and you can test it. But obviously in conventional method, it will be very difficult. That's why if you take 10 years before, there for a development of a new product from the old version will at least take 5 or 10 years. But now it is not there because of this model based design. Okay, because of this model based design, software help us to eradicate all this problem that is held us or stop us in doing connecting that requirement phase along with the testing. Okay, that has been actually minimized with the V workflow that we will discuss in the future slide. So, reusability of the code. And one more problem, coding, since all the algorithms, all the SOC, SOH, battery health, battery management, your motor speed, motor temperature, everything will be monitored by the software. So reusability of the software will be also very difficult if your software is in the programming mode, that is in the script form. So whenever you want to update, you need the time of the software team to develop a new code out of it and give you a software to you to check and make the updation. So which you will ultimately lose the time to market. Okay, and traditional testing methods. So this will automatically making some integration, making the software team to deploy, rectifying their errors, and the hardware team need to check whether everything going fine, strategize and bring back, make the validation, give the insights, and make the entire design process to and identify everything working fine. And there will be no traceability will be there for the next version. Okay, because all the rectification has been done for the older version. Suppose you are moving to a new version of the model, if you don't have an integrity model, if you don't have an integrity platform where the hardware software are together can be tested, if you don't have such an environment, then no traceability will be there. And your new version, your learnings will not help for your new version. That's why aftermarket products are getting defective if you are not using this methodology of model-based design. So those are the problem. So as I was stating, like you need to fix on the requirements. You need to fix on the requirements. If you fix the requirement error, and you can say like almost you will be left to only 10% of you will be having only 10% on the issue on during the testing that you can fix during the testing mostly. So you need to make sure in the conventional methodology, you need to ensure that your requirement and the design should be cope up will be 100%. Then you no need to worry on testing. Okay. Yes. How to achieve it? Actually, that's the next question. How you will actually achieve it? How you can ensure your requirement and the design is working proper, and where you can actually test your hardware and software is working fine, and how you can reduce the time of deployment of your software or your program that is deployed easily to your model, your control system or automation or your car or whatever the thing your product is all about. How you can reduce the time between this hardware software mapping, and how you can actually reuse your existing model to the new one. That is very, very important. So if you see here, actually this is a graph give you a glimpse how the error uh, the error can make significantly make the project down. Okay. Yes. So here we have given the phases. In this graph, your y-axis, they have given the relative cost to fix an error. Okay, so what is the cost? That may be like not only financial, including the hardware also. Okay, and in that, sorry, that is in y-axis, and in your x-axis, we have given the phases. Okay, so requirement phase, design phase, coding phase, and testing phase. So 4 phases are there, right? So in brown color, you can see that is in the requirement phase. Okay, and the orange one is the design phase, and green one is the coding phase. So if you see in that first one, requirement phase, so the error introduced in the requirement phase can be easily rectified, and you can easily fix in the requirement phase itself. Then that is okay. Then you won't get trouble in your testing phase. If it is in designing phase, okay, if you have problem in the requirement phase, that will be affect more in your design phase. If you are in coding phase, if the error is in coding part, yes, you can rework on coding easily. But if you have error in the requirement phase and design phase, it will automatically, your coding phase will not fix these two things. Similarly, in your testing phase, if your requirement is not properly identified, then you will have more burden on the requirement phase, designing phase, and testing phase. Simply to say that once your requirement is perfect with your design phase, usually you won't get problem in coding phase and testing phase. Okay. So if you identify at that time of testing phase, your design is not okay, your requirement, what are the component you have purchased is not okay, then just check. You cannot rework, because in that entire model will lead to failure, and you need to rework for this. Why we are actually discussing too much on this? Because when you go for massive production, you need to like 200%. You need to 200%. You need to have that quality of the product and confident over the product. Then only you can go for the mass production. Usually, the team will insist this mass production will not like stop like 1 or 2. It will go in lakhs. If you take cars, minimum they will go for a minimum version of car, they will go for 10,000 to 20,000. So the loss for the company will be huge. So no one will recommend, no one will give you an assurance unless otherwise your requirement and the designs are good. And once that is fine, then only they take it to that production level. There are several automobile cars. Car has been actually designed, but they have not launched because of this requirement, and the design phase are not working out. Okay, so this is the problem. So how to fix it actually? So here this model-based design will come into play. This will help you to fix it actually. Here you can share it. You can take like this model-based design tool like Simulink and Simscapes, or you can go with other softwares like LabVIEW and SolidWorks, which help you to make these simulations. Multi-domain simulations will help you. Okay, so you can actually build a model in that particular software. Okay, and you can make some like you can make some easy integration. You can actually do with that software. Okay, and you can check whether your requirement and designs are okay. Okay, that's where nowadays we are getting new products. Then like within 3 months, we are getting a new version of mobiles are available. Within a year, we are getting new version of cars. How it is possible? By adopting this technology called as model vision. What is the stakeholders idea? What is the idea behind? Yes, go to the software, open this model-based design tool like Simscape or your LabVIEW or SolidWorks. There are several other softwares also there. You can open those software. Try to build that integrated model along with your electricals, controls, softwares, and the mechanical parts. And here, just to give heads up, Simulink will give you all the control platforms, and SimScap will help you on work on that real environments like mechanical. If you want to build that robotic system, yes, all your robotic parts it is available under SimScap tools. So you can take that SimScap product, download it, install that version. You can build your entire robotic model in that SimScap model, and all your control systems can be built with the Simlink. That is possible. If you want to go ahead with the AI development, yes, go with AI. You can use MATLAB, okay, and you can do your algorithmic work in the MATLAB. So all the three products you can use simultaneously to build your perfect model, and you can do that automatic code generation, deploy those code, and you can test with the real-time robotic model as well. Okay, this multi-domain simulation model that is possible with this Simlink and SimScap tool, and other model-based design tools are also available, which will help us in saving the time in a single simulation environment. Okay, all your hardware, software, integration test, modeling, multi-domain specific things as optimization, early detection of error, all these things you can perform in this multi-domain simulation model. Okay, and this will help you to, since we are not going to buy any of the components from the physical world. See, if you have the software, once you purchase the software, all the components what you want to do with the robotics that is available with that particular software. So you can just pick and place connect this model, and we are not going to buy any of the components. And all the industry standard components are already built in the libraries. You can pick, and the exact version you can make a replica in the system, and you can continue the working with the control system, and you can deploy the code easily. Okay, so no cost will be involved for your prototype. That is very, very important. That's what the industry is looking for. Cost for prototyping, no one is actually nowadays they're ready to do that. Okay, once your prototype is ready, they want to, nowadays companies are looking for launching. Once our first model is launched, once our first version of the model is launched, they are looking to launch the second version as soon as possible, because no company want to be like staying back or just launching and keeping quiet. No, they want to become the market leaders. They want to rule that particular industry. Okay, for such people, such rapidization, such fast-paced development, this model-based environment can help us to do that. And you can make continuous simulation out of it. And as we suggest, as we discussed, we can do that continuous simulation. Yes, and the easy integration can be done, because this multimodal domain analysis we can perform, since the blocks are designed in such a way. You can use these blocks without any hassle, and you can connect with the different simulation environment, different simulation multi-domain environment. You can connect and model. Okay. Yes, coming to the very important concept for this model-based design called as V-shape workflow. Okay. Hope I think I am very clear with the concept which we have discussed on this model-based design, right? So what is this V workflow? So why this rapidization we can see in this industry in the past decade? We can see a lot of things is happening, and we can see the things are rapidizing, and we can see everything happening in and around in a very fast pace, right? And how this is possible? Have you ever think how an engineer or a technology people can give a product in a very short notice, that is with a high quality and the features and at a very low cost? How that is possible? Most of you experience like we have purchased a mobile, like people who have purchased mobile like 10 years before. For that cost, what we paid, we are getting only very, very basic stuff that is available in that communication. But what happened now? Even for a very affordable price, we can get everything that is there available in that mobile and the communication tool. If you go with that automobile cars, nowadays slowly, if you can witness, the EV car prices are getting below than 10 lakhs. And slowly you are going to experience, like in the down the line, within 5 years, you can see even your kid will have an EV car. Even your kid will supposed to have an EV car with AI power. It will automatically make the drives, and it will take wherever they want to go. In the down the 5 year line, the down in the 5 years, we are going to see all this stuff. How that is possible? How an engineer can give a product in a very affordable way? How he can provide a product without like zero errors? How this fast rapidization is happening? So that is due to this particular workflow called as V-shaped workflow. Okay, we simply call this the way to look back. The possibility to look back at different stages. Okay, so this V-shaped workflow is such one of such thing where the look backs are possible. Okay, so here the 7 stages they have given from the V-shaped workflow. So 7 stages are available. So one second. 7 stages are there. So first one, as usual, requirement stage. Second one, system specification level. So multi-domain requirements. Okay. Third one, subsystem domain. Third one, subsystem implementation. Sorry, fourth one, subsystem implementation. So this left-hand side is design phase. So in the right-hand side, we have the integration and testing part, subsystem integration, system level integration and testing, and third one, complete integration and testing. Okay. So design phase and testing phase. So in the left side of this V will be your design phase and the right side will be testing. So in the conventional method, what happened is that you don't have this look back mechanism. Okay. You don't have a look back mechanism because whenever you cross one particular stage, whenever you cross this particular stage, once you cross this requirement stage, meaning that you don't have an option to go back and change the requirement or design. Okay, there is no more option for you to change it, to go back and change and look for the requirement or the design. So if you go and touch, okay, what happens, sir? Okay, if I want to change something, okay, I have designed the car for 1000 cc. Suppose I want 1500 cc. I want to improve the power of the car. So if I want to go and change the powertrain, if I'm going to touch the powertrain, then your entire design needed to be reworked. That is not possible on your conventional method. And system level specification. Once you define the system level specification, this is my control system, this is my communication system may happen, this is my range and this is my power, this is my vehicle. Once you define that, you cannot change after you are making this subsystem. So you once in your conventional method, your design is fixed one. Okay, you cannot go and rework. If you rework, then you are end up into a new version of the model. Okay, and testing and integration phase, that is directly rely on your left side on your V shape. Okay, that is directly relying on your first 4 stages. Okay, so this model based design will help us to adopt this V shape workflow. So what is this adoption is meaning? How it will actually help us? You have an option of look back because this entire model is built on software. It is not in the real time. So this simulation environments give you a hand where you can actually make a look back even if you are in the complete testing phase. Okay. Suppose if you are going to test your model tomorrow, today you have an option, today you want to make a change in any of the phase in the left of the V. Okay. Yes, you can sit back and rework because all the stuff what is happening in this is happening in simulation environment. Okay. So no more cost problem, no more trouble to change the component. Whenever you change the component, the extra parameters will be appeared. You can work on the block parameters, tuke it, and connect it to your existing model. And yes, you have an option to look back from the testing and the phase of integration. That's why we are getting the rapidization of a product. And you can witness few things as, and the version of the car, the entire model of the car will be the same. Only the updation will be changed. For example, if you take like 5 years before, the cars are coming with 2 airbags as a common standard for safety. Now you check, most of the cars are coming with 6 airbags. and all the nowadays the cars are coming with the IoT feature enabled. Okay, so if you check with the older version, the entire model of the car will be resembled the same. The entire version of the car will be looking same. Only the updation will be one. Only the where the updation to be happen, only that particular portion will be changed. The rest of everything will be untouched. Okay, so this is how the rapidization, fast phase of rapidization is happening, and the background of the engineering, if you check, they are using this V-shaped workflow and this model-based design tools. Okay, yes. So let us take some study. Okay, sir, you have discussed a lot of things as model-based design, the option to look back from the testing and implementation, and the code generation is automatically happening. You can do control system, you can connect this software, sibling and chips can give the everything fine. Is there any user story or any user story is there whether they have used this and any success they have done? Yes, just see the screen. So this is Aurora actually. So Aurora is an autonomous aircraft actually called Aurora Centauri. Centario. This model based, they use this model based design. They have used with MATLAB and MATLAB Simulink and SibScale. Okay. So this entire flight control. So what this where they have used this model based design? Actually, they have made an autonomous flight. Actually, this Aurora is an autonomous flight. The entire flight control, vehicle, mission, and flight management software was done with this model based design. So there are many challenges for them. So they have listed many challenges because maneuvering is flight is not that easy as driving car. Okay, you need to take care a lot of steps. Okay, so the entire control flight management system has been done with this model-based design, and still now they are using this software for their maneuvering design. And all the challenges that is involved in modeling aerodynamics, propulsion system, electrical system, flight control, instrumentation, monitoring, parameters, everything they have done with MATLAB and Simulink, and using this MATLAB and Simulink is constructed with this model-based design tool. So this prototype is very expensive, but they have successfully done with this MATLAB and Simulink tool, and still Aurora all flight management system was inspired with this MATLAB and Simulink tool. Second one, ATAL, and this is one of the very special story from the famous EV manufacturer ATAL, and this is they have done this SOC and SOH battery management, motor driving capacity, and they have started with 60 kilometer of range, and now they have achieved up to 80 kilometer of range top speed and capable to drive 150 kilometers. Capable to drive 150 kilometers. So what is the challenge they have taken with us along with the model-based design software? They have come up with us to design with an intelligent electrical scooter, meaning that the entire system, the entire vehicle to be managed and controlled with the software. Yes. So they have used this model-based design tool to simulate and optimize the scooter design and generate production code out of for its control of this software. And you know that this software is very popular, and in Bangalore more than 5 million two-wheeler scooters are used above for the transportation. So you know about Bangalore, the traffic, and Asia's very highly dense traffic city is Bangalore. And you know about the noise pollution and CO2 emission is very high. So Aether has connected with that transport corporation to launch this EV model and to test this EV model. which is capable of accelerating 0 to 40 in 4 seconds, and the Ether 450 has achieved this as stating is a top speed of 80 kilometers and a range of 75 kilometers in a single charge. So the Ether engineers design and optimize this copter with MATLAB and simulation software. And by running this simulation in our model, we are able to test this design idea and understand this how this software is actually working and how this particular Ether model is working under different condition, and it is inclined towards tested with multiple riders, experiment with different temperature, and with battery and different batteries, and how the performance of the motor with the different condition. Later, they use this model-based design software and make from an end-to-end algorithm development was done, and this software helped them to make the design through validation and code generation has been happened with this model-based design process. Okay. So the challenge for them, so to make this vehicle comfortable for the rider, to need to satisfy the rider range, and need to give the power to the rider. At least two pavilion can be, and at least one driver, one rider and the pavilion can have a comfortable, smooth ride, and they have analyzed lot of pattern with them and come up with us, reach us to make design. So here in the screen you can see what is the result they have achieved. So the design alternative, after making the study, and they make a design alternative evaluated in the week, not in months. Ether has mentioned, Sivaram, who is an NV, an engineer at Ether, he has mentioned that he's a system engineer there. He mentioned that they have already tried several other softwares, but by adapting this model-based design, they have end up the evaluation based on the user perspective. They have customized the vehicle, and this evaluation they have done in a week, not in months. And the time for testing is obviously reduced. Why? Because model-based design give you a look back where you can have an option to rework on the requirement phase. As I was stating, once your requirement or design is perfect, then your testing time will be gradually reduced. So that's how they have reduced 50% of the time involving in this, and field rapid test issues was reduced. Because why? Because this software has an auto code generation. Auto code generation was there with this tool, which helps them not involving a separate software team to test and validate. You can directly connect this software once your model is okay. Once your requirement and design is 100% fine, fit in, then you can directly connect this and make analysis, live analysis to that software and connect with your vehicle. Okay, that is possible. So field issue rapidly resolved. So this helped them to release the new version of the Ether. Okay, with this model-based design. That's the current version which you are seeing with the Ether they are using. That's how the model is very successful, and the time to market is achieved, and the Ether is still in and week in maintaining the top position in the EV vehicle. So not limited to that, not only like electrical, not only limited to electrical vehicles, we also involved in ATAL fuel management system. So Airbus, I think most of the flight, whatever you are seeing in the sky, that you can say like the top manufacturer is Airbus. Okay, so they have come up with this product called a fuel management system. Okay, so and this is also involved lot of complex mathematics and mathematical modeling steps are involved, and we need to make that cross testing also. We need to done with this fuel, because this management involved with 2 to 3 different cross-platform testing we need to do. Okay, because the control system is designed in such a way where the control system is running in a different one, and the version of fuel management system and algorithm. We need to test all these 3. Okay, and we need to ensure that this is platform free management system. Okay. So the challenge is to develop a control system for the Airbus 380 fuel management system, and the solution we have given from our software, which is MATLAB and assembly. And they are using this use the state flow model to develop this design to model. And this model has been taken. And what is the problem? These EA380 are the largest commercial aircraft. Actually, these are some of the commercial aircraft which will be flying for non-stop more than like 8,000 miles. Okay, these are commercial aircraft that are flying for 8,000 miles. So we need to identify and we need to work for this fuel management. So more than 11 fuel tanks will be available. Okay, and 250 metric ton capacities of this flight. So which is ensuring about 3,20,000 liters of petrols will be consumed. Okay. So such an huge and massive control system, we need to plan for this handling this fuel, and we need to ensure the fuel has been taken in a very wise manner and optimize to that aircraft center of gravity as well. Because this fuel system, it is available to this aircraft, and we need to ensure this fuel system is also taking care of the center of gravity of the flight. We need to make sure, and you people know that this fuel system is entirely distributed over the aircraft, including the wings as well. So the center of gravity is very, very important. So the fuel should be taken in such a way so the center of gravity of the aircraft is maintained. Okay, and keep fueling in that acceptable temperature range as well. You know that this is a flight is traveling for very long period, very long time. It is there in the air for 8,000 miles. Okay, so we need to check for an acceptable temperature rate. The fuel should be travel and the fuel should be taken in such a way that the center of gravity with the aircraft is also maintained. Okay, so where you will go and test. So how you will make a model out of it, whether your prototype will help for this. So for such a complex system, how you can perform without touching the physical model. For that, model-based design tools are available. This SimScape and Simulink will help you to design this entire physical parameter of the entire your flight is there in your SimScape. You can bring all those once install your SimScape, corresponding tools are there. You just bring that, build your model, and you can perform the control systems, all the stuff with your Simulink. And yes, your algorithmic patterns and the pattern of distribution, weight balance, everything you can perform with MATLAB. And all the multi-domain analysis you can perform. Once your model is ready, yes, you can directly connect your flight control system with our software and you can perform this model-based design. So what are the things we are going to achieve out of it? First thing, we are going to achieve the balance of the flight. Second thing, we can understand how the machine is going to behave in the real time. Third one, it can eliminate the time requirement actually. That is the very, very key thing. Time to market is very, very key thing for any manufacturing people. Okay? And we can reuse what are the advancement that is kicking in, what are the advancement that is pitching in. We can actually reuse with that particular advancement because these tools are multi-domain tools and they have their own interoperability. Okay, and the complexity and additional complexity handling with the staff without staffing is increased because we don't need separate team to work for the different type of the control system or a different type, because once your model is done, we have confidence to go with deployment. So that is very, very important. That can be achieved easily with this model design. Okay. Yes. In the short note. Yeah. So benefits of this continuous testing and verification. So as we see that testing and verification. So your model-based design gives you the testing and verification involvement in all the phases. As you see in the diagram, your testing and verification has the complete vision to all the phases where you are involved. Okay, except the research, because research is belong to the updation. Apart from that, elsewhere you have an option to test and verify. And if you find the changes to be happen, yes, you can go and make that happen. Okay. Yes. So now we have get some idea with this software, right? This we have already discussed. So um, that's all about your model-based design. So what it will help us, it will give you, it will give us a vision to look back, and it will you can easily adopt the V workflow. That's why the industry rapidization is happening, and we have the mechanism to ensure our design is ready, and we can reduce the requirement phase error, and our model is ready to go, and we don't need separate software team to make. Uh, the system to deploy the codes, it will automatically generate the codes. And yes, you can actually test along with and take that data. If you want to manipulate with the real-time simulators, yes, there is an option for us to do that real-time simulation. Real-time simulation manipulators can be connected with the software, and you can do that. Once you 100%, if you are confident with your model, yes, you can go and do it. Your uh, real world machine, actually your control system, you can connect with that hardware and you can deploy the code and you can run it. So these are the things that help us to make the rapidization in the industry. Okay. Yes. So where you can actually kickstart. So I will give you some glimpse. Most of you know that about our software. You can actually suppose if you want to do. Okay, sir, I understand what is model-based design and how this V workflow is actually adopted, and several success story you have mentioned. Yes, how we actually can kickstart. Okay, that is very simple. MATLAB give you an option to go with this MATLAB Academy. You can actually you just type like www.mathworks.com. You can reach there. There are several self-paced courses are available. You will call this as on-ramp courses. You can do these courses and understand how you can actually start working on this tool. Okay. And once you complete, you will get a proper science certificate from the director used, and you can start working on this tool for your own model-based development. And several nowadays we are concentrating several web series available for you where the engineers and techie people can reach us and start doing their own work, their own domain-based expertise. They can come back and check with us, check with our workshop series. You can start doing along with us actually. So there is we have created an created an resource-based things where you can sync up with us and you can also grow with us. That is also possible. And see, Manakula Vinayaka, we have a campus-wide license. They are very long partner with us. And yes, we have set up several training and workshops along with us. So people who are has a facility to reach Sri Manakula Vinayaka College of Engineering, please be like whenever we conduct a workshop, yes, you please reach them. We can actually collaborate, and that's how the learning should be happen. So when we collaborate, we can reach several, we can share our knowledge and we can reach to the new heights. Uh, so with this, we don't want like I don't want to take too much of the time since we have a lot more things. Uh, so I like to be open for the discussion. Like next 10 minutes is there for us. Uh, so I open for the discussion.
Participants, you can unmute yourself and can ask questions.
Yes. So there are a lot more things is actually is there with us. If we take the entire session, will be like things will be taking more time to discuss. So I just with that content I am stopping like model based. I think hope you understand what is model based design, how this V workflow. You can actually adopt this V workflow in your project as well. And you can bring it up. Actually, after understanding this concept, nowadays our team, including in our solution, we are doing several projects. We have actually started working with this model-based design. So that's how we are achieving several new milestones as well. So you can actually, even if for a simple project, you can try to do this model-based design. Okay. So any questions? I am open for discussion. We can discuss on that.
Yes, ma'am.
Good evening, sir.
Good evening, please.
Sir, as you say, if we combine the SimScape and the Link model,
Go ahead. Yeah.
can you hear me, sir?
Yeah, ma'am. Sure. Go ahead.
If we are connecting the SimScape as well as SimLink, as you are telling, like designing the EV part. So, if
Correct.
the vehicle dynamics has been designed in SimScape and control logic and the motor is in SimLink, whether SimLink as well as SimScape model can be implemented in a that
You
is
want to run in
real-time
parallel.
simulators. Real-time simulators.
Okay, real-time simulation. That is possible. That's what the special of the tool is, that you can actually, the first thing is that you can actually run Simulink and SimScape together. That is possible. Second thing, you can actually connect with the real-time hardwares. So that is the power of this tool, actually. In any model-based design, Simulink is one of the, Simulink and SimScape are the model-based design tool. Any model-based design tool has an option of automatic code generation. Okay, there is a facility where you can actually connect this software to your hardware model, and actually you can connect actually though your EV microcontroller can be actually connected with the software, and you can actually make the entire control that can be processed from the concept. That is possible.
Hello, sir.
Yeah, yes, sir.
Myself, Dr. Manish,
Go ahead.
working
Yeah,
in Jaipur.
great.
Sir, so do you provide directly internship to the BTech student in the Bangalore company?
Uh-huh. So you can reach us. Please feel free to reach me. I'm sharing my contact detail in the slide, or you can reach Dr. Sivakumar, and we can actually discuss those things in separately. Okay.
Sir, also I attended one last FDP, one
Yes.
regarding professor from Triple IT Jabalpur presented many work in
Okay.
my lab regarding additive manufacturing.
Oh, okay. Great. Yeah.
So I want to know, sir, can we simulate the deposition in
Mhm.
my lab?
Yeah, sure. Let us check with the requirements. Manish sir, let us check with the requirements. Please feel free to reach me. We are there to help you. Let us check with
Okay.
your requirements. I will share my contact details as well in the presentation
Sir, I
itself.
also request you please share the slide with all the participants. It will be helpful to all
Sure,
of
sure,
us.
sure.
Okay,
You can actually reach Dr. Sivakumar for that. I will share everything to Dr. Sivakumar. He's a, so you can reach him. I will share my contact details here as well in the chat as well. You can feel free to reach me.
okay, thank you, sir.
Thank you so much, Manish Kumar sir. Thank you.
Hello,
Murali
sir.
Krishna sir. Yeah, please go ahead. Sir.
This is Venkatesan from Erode, sir.
Venkatesh, sir.
Hello.
Yeah, thank you,
Is
thank
it
you.
audible, sir?
Yeah, you are audible, sir. Connect.
Sir, whether student version of these softwares are available so that we will get pre-introduction to them?
Uh, Actually, it is not student version stuff is not available. See,
Oh,
but yes, you have a trial version where you can actually kickstart with your
okay,
Gmail
okay,
account.
okay.
You
And
can
that's what.
kickstart.
Okay.
And yeah, several institutions we have connected, like ESM, VCE, we have already connected with them. We are doing several session technical trainings, and we are doing several projects with those very pioneering institutions. We are doing those
Oh,
support.
sure, sure.
Feel
Okay.
free to reach. We are actually about to conduct several sessions with Sri Manakulam in area. So you can actually
Okay.
connect with the team, and you can take benefit out of it.
Okay, sir. Sure, sure.
Sure. Thank you. Thank you for.
Any questions, sir? Any other questions?
Any other questions? Yeah, feel free.
chatbot that is question here. Open source or student of these software. Sir,
I can't reach you, sir. What happened?
in chatbots,
Chat box, okay.
that is a participant raised on question.
Okay.
Open source or student version.
Student version of the software. I can't get you, sir, actually. So what is the question? It's all about...
I was asking whether free version of software is
Free version. No, that's not possible. So you actually, the power of software is actually something we can say like this software, once you start exploring, once you start passionate, this software is a different world actually. So this is like mathematics, you can say like subject, mathematics subject. So most of them, like if you check with people, they a little bit get fear of the mathematics. No, I don't want to study. Or getting pass in mathematics is more than enough. But once you're getting passionate in mathematics, then everything you will see as a math. Similar the way this software is also initially was developed for the mathematics purpose only, but after that it is moved into engineering and technology. Similar way, like once you get passionate or start working, the power of this software is limitless. That's why this software is not available for free. Okay, yeah. Once you get passionate, you will start thinking everything in the MATLAB way. Can simply say like that. So the free version is not available, but still you can reach the pioneering institution like SK Manakula Vinayagar, and you can actually request them. And several trainings are going about to happen in there. You can actually request the coordinator and the people out there, and you can still get the benefit out of it. There is no doubt in that. But yes, their software, free version software is not available.
Sir, I have one more doubt, sir.
Yeah, yes, ma'am. Go ahead.
Sir, for example, for a EV drive, if we are using a motor, as you said, if it is a PMS motor, then
Okay.
if we are going to use a controller, if it is a field-oriented controller,
FOC,
then there
okay.
will be yes, sir. Then there will be a 3 PI controllers
Yes,
in FOC.
correct.
So, with the help of auto tuner block, how can we get the values of P and I, sir? Because the auto tuner block will work only for a single, that is first a single order system. If it is a complex order, then it will not tune.
Correct. So what you need to do is that you need to that's where your SimScape come into play. Suppose if you are looking from the perspective of control system, the system to identify uh, your stator and rotor current in that 2D model, okay, that will be difficult for you. But if you go and design in SimScape, okay, design that model, the entire EV model is available in SimScape. You can take the entire EV model. I hope you know about Clark transform, correct? Where
Yes,
you
sir.
can actually remap from your 2D perspective into 3D perspective, and that will
Yes.
help you to align your rotor and start make the initial rotation and guide that. That will help you to guide that FOC, correct? So
Yes, sir.
that entire model, it is available in SimScape. Okay. Feel free to reach me. I will. One second. In the chat, I will give you my mail ID. Okay. Just drop a mail.
Oh,
I will
sure, sir.
share you. I will share you the entire model, and you can directly use that and start running it. Actually,
Okay,
you can
sir.
understand
Okay.
how this Clark transform is working, how this FOC algorithm enables that PMS MS model to work. Everything. Okay. Just dropping me an email address. Just drop me a mail. I will share you the model.
Yes, sir. Sure, sir. Thank you, sir.
Okay. My mail ID is there. If still you are unable to reach me, you can reach via Dr. Shivakumar.
Yeah, thank you. Mr. Juncture, I would like to invite Mr. J. Muruganandam, Professor, Department of Fishery, to complete the session with thanks note.
Good evening, everyone. It is important to deliver the vote of thanks for the behalf of management, Department of Electrical and Electronics, and to extend our sincere gratitude to Mr. Gautam Rajmohan sir for sharing his valuable insight with lot of real-time example for model-based design. Thank you, sir.
Thank
Finally,
you. Thank you so much.
thank you to all our active participation and enthusiasm, which made this even more meaningful. Thank you once again for all the participants.
Thank you. Thank you, sir.
Thank you so much. Thank you so much. Thank you all. Thank you all for participating in such a wonderful event. And I hope the session will help you. Please, if you have any suggestion or if you want any support in this model-based design, feel free to connect via mail. I'm sharing my mail ID in the chat. Thank you so much.
Dear sir, madam, the second session is automation and robotics, integrating automation in production line. By Associate Professor, Indian Institute of Technology, Indore. I would like to invite Dr. D. Sivaraj, Associate Professor, Department of FDP, to introduce our resource person. Good evening, Dan, sir.
Sir, good evening, Dan Satyai, sir.
Hello.
Good evening, sir.
Yeah, sir. Good evening, sir. Are you able to hear me?
I would like to invite Dr. D. Sivaraj, sir, Associate Professor, Department of FDP, to introduce our resource person.
Sir, good evening, sir. It is my privilege to introduce our esteemed speaker, Dr. Dan Satyai, sir. Dr. Dan Satyai, sir, is working as an associate professor in the Department of Mechanical Engineering at IIT Indore. He completed his PhD 2016 from IIT Hyderabad in the area of thermomechanical processing of high entropy alloys. Before joining IIT Indore, Dr. Dan sir was worked as a postdoctoral researcher at TU Dresden, Germany from May 2017 to November 2019. His postdoctoral research was funded by prestigious Alexander von Humboldt Foundation. His research area of interest are advanced manufacturing, micro, nano machining of high entropy alloys and additive manufacturing of these advanced high entropy alloys. He has published more than 30 papers in international journals. So we are honored to have Dr. Dan Satyai sir with us today to share valuable insight and expertise that will enhance our knowledge and skills. Let's give a warm welcome to Dr. Dan Satyai sir. Welcome, sir.
Thank you, sir. Thank you for your introduction. Nice introduction. First of all, I would like to thank the invitation from Professor Raja, Electrical Department, Professor. Also, I would like to thank the management of Sri Manakula Vinayar Engineering College from Puducherry. So now I think I could able to share my slides. Can I share my slides, sir? I hope. So are you able to see my slides? Hello?
Slide show, sir.
Yes, I'm just. Yes. Is it okay? Yeah.
It is okay.
It's okay, right? Yeah. Okay. So first of all, thank you for the invitation. So today, my proposed topic is automation and robotics, integrating automation in production line. Okay. I hope mostly here people are from electrical and electronics background. Maybe some of the people from mechanical also, maybe many of the faculties also might be present there. So before going into the topic, so what I want to do is like little bit basics about robotics and automation. We need to understand that. Then only we can go into this topic. It's like then easily we can understand it. So that's what I just make it into mainly in an introduction part. I make it like robotics and automation as a separately. Then I will just integrate the both. Just like a topic, I just integrate the automation in production line. Then some of the case studies I will show you. So tomorrow I will mostly talk about my research related talk. Today mostly I will given some kind of case study and some of the examples. I try to give it. Okay, like that's what I just divided my topic into two topics. Maybe tomorrow you may hear about additive manufacturing, and then about this subtracting manufacturing like CNC machining. Also, what is my area like high entropy alloys and like some of the new advanced alloys, how we can do it by additive manufacturing. Those kind of topics I will cover it tomorrow. So today we'll try to basics of this robotics and automation. I'll try to do it. Okay. Uh, Hope all of you know about the what is robot, right? Like uh, people may think about if you call it like a robot, we may think it of the humanoid robot, but it is not necessarily the robot not look like a human. So it can be like a only it can use like a we can use the arm, or it look like some resemblance of the parts of the human. So then it is basically it is call it like robot. So industrial robots under it won't look like a humanoid robot. Okay. So it is it is automated operating machine that will replace the human effort without any resemblance of a human. Okay. So the concept basically it it came from in the 90s only, but we don't know exactly know the where it is recorded in the history. Okay, so mostly if you see the robot, basically it is come from the Czech word robota. It's called it like a forced labor. The meaning of that meaning is forced labor. First, this kind of robotic play is happened in 1920 in the Karl Čapek's play. Usually, they showed this Rossum's Universal Robots. They show it in the play. Also, the first word, robotic word, is appeared in the Isaac Asimov's science fiction story. You can see this run around in 1942. Okay, so also this run around topic, they have covered this basic three law of robotics also. I hope you may know about this basic law of robot. So it may not injure a human being through the interaction, allow a human being to come to harm also. Okay. So it should basically the second point is the robot should follow the order by the human being, except where such order would conflict with the first law. Like if it is conflicting the first law, it won't obey the second law. So also it should protect the robot can protect its own existence, but at the same time it cannot conflict this first and second law. Okay. So this is the basic three law of robot. So usually here today we are mostly talking about industrial robot. So basically that evolution I am going to talk about it. Okay. The first stationary industrial robot was it is called like a programmable called Unimate. Okay. So it is basically it is invented by the American engineer called George Devil. So he first invented this uh, industrial robot. Okay. Later on it is developed by the Unimation Inc. company. Okay, in 1956, by this American engineer called Joseph Angelberger. So basically, he developed this particular industrial robot. Then he introduced in the Unimation Inc. company. Okay. Also, the first prototype was basically implemented in the General Motors Corporation in the year 1959. Basically, they did it for the die casting factory. Okay. The first the production line serial robot was delivered to the General Motors in 1961 by the Contact Corporation. It is Contact is nothing but it is acquisition of the Unimation Inc. Basically. Okay. So if you come to the thumb rules on this decision of robotic uses, basically where we will use this robotics means basically there are four environments. Basically, we will try to replace this human efforts. Like for example, the task is really dirty task, then you can use the robot, or some kind of dull kind of environment. Dull means like kind of repetitive work. Where there is repetitive work, there basically the human is not much needed. So there you can replace the robot. And also for the dangerous environment, for example, dangerous means suppose you have to work in the nuclear environment or some kind of radiation environment, then in that cases you can replace the robots. Also, that is for some of the difficult task. Also, you can adopt the robot. Difficult task means For example, suppose pick and place. For example, I'm just saying this pick and place robot. Uh, Suppose we have to handle the 1 kg or 2 kg object, means we could able to, the human can easily handle the any of the part, but the part size is the weight is like going beyond the 5 kg or 10 kg, then it is very difficult to handle. So in that time we can use the robot arm or robotics for the uh, for this environments. Okay, so but at the same time the usage of the robot may not leave a human jobless, whether so it should, one can find the people those who are willing to do the people, like then we can go for the whether how it is impacting in the short term or long term economic sense or industry point of view. So then based on this thumb rule you have to select it. Okay, so for example in case of industrial robotics, so we can find many areas people find the robotics nowadays, people are using it. So for example, initially they found it in the welding, robot welding, spot welding, also the material handling robot. They are using it in the pickling, painting, assembly. So these are all the applications they have used it. So maybe better I can show some video from the YouTube. I hope a lot of data is there that might be it might be useful for us. Like you can show the application here. So you can find it like here it is. Basically, it is they are using it for the spot welding. How this robot is doing the spot welding, you can see, and material handling, like how this cup is how it is exchanging this cup. You can see basically machine tenting means kind of machine tools. It is using it for the different machining operations, like different machining tools are there. It is handling these tools. Here they are using it for the painting, like this automobile body is painted here, like okay, you can see here. Also this packing, pickling, picking, this kind of application. One conveyor to another conveyor, it is transforming. Assembly, how it is used in the assembly, you can see here. And also some of the mechanical cutting and polishing operation, how it is performing. You can see here like the different cutting operations, laser cutting operations, some of the polishing operations. So also it is doing some kind of adhesive sealing, like gluing kind of thing operation. Just it is attaching the parts together, kind of assembly operation. Again, it is a spraying. Some of the other application also, like we can find it like PCB boarding, assembly. Like I hope you may know about the PCB parts, like right. It is all made up of very micro electronic mechanical components. So for that and all, so we can use this different application. We can use this robotics. Sorry. So apart from that, we can use it for the robotic, for the medical robot, mining, space robot. There are advanced applications. These are all underwater exploration. Nowadays, even our defense also they made this defense robot. Thus, it is basically it is act as a bomb diffuser wherever this dangerous job is involved. So it can diffuse the bomb, and I hope this UAV Netra. It is developed by the DRDO. This drone, basically, just it is a border application, like border surveillance. People are using it. DRDO, like defense, are using it nowadays. So these are all certain application of the robotics, and also some of the, like suppose the car is they are risking it from the very like from the ice. So also some of the robot here, the boss they made it for the agriculture robot. It can be used for seeding purpose, and like it can remove the seed. Those kind of operation it can perform. Like this, many of the areas, so you can find the industrial robot application. Okay, but if you come to the industrial application, so here our talk is basically um, here we are only confined to the industrial application. So industrial application point of view, here there are three types. Basically, it can go ahead. It like one is like material handling. There, palletizing and packaging is very important. If you come to the processing, there are variety of processes are there. Like for example, it can be a welding, it can be a machining, or it can be a surface finishing, painting, drilling. There are many operations are involved. Assembly means again it has to do some kind of collaborative task and basically needs the compliance. Okay. For example, there are two types of robots are basically there, serial and parallel robot. So in industry, basically, in industry we are using industrial serial robots. Okay. For example, mostly if you take the serial robot in the sense, what I'm trying to say is, suppose the link is connected to the arm again. So, for example, if you see the right side diagram, the base is there. There, one arm is connected. Again, the second arm is connected with this link. Third arm is again connected. Then tool will be it is connected here. Like this is basically the tool pick and place tool. The fifth one, what I'm showing here. Uh, so there it will act as a end effector tool. Okay, like here this end effector based on the usage, you can change this tool. Like suppose if you are using a grinding operation, then grinding tool you can put it. Like suppose if you are putting painting operation, then spray gun you can keep it here. Suppose if you are performing welding operation, then welding gun you can place it in a end effector tool. So it will act as a end effector tool. So basically, it has these the manipulator have serial or parallel arm. That is basically it is called it like a robot manipulator. I will tell you what is parallel robot also. So in serial case means you just understand that it is serially it is connected. Okay, serially the links are connected with the arms. Then in order to operate these links, we need a controller, right? So here, suppose for example, here if you take this is the fixed here in the floor. Basically, it will be in the near to this bottom one. The controller might be there, or you can use a separate controller. Like suppose here the separate controller they are using it in the figure. The two is basically it is telling the controller hardware and software. Third one is the teach pennant for programming. Basically, teach pennant means basically we can program it that what is the location it has to go and where it has to stop. All those this programming you can do it in the teach panel. So that is for the programming. And the connecting cables mainly it will connect all the power sensing pneumatics. Basically, it may connect the hydraulics or pneumatics because we have to activate the heavy loads. So for that we need to use this. So connecting cables through that it might be connected. Again, end effector based on the application you may use the different type of end effector. You have to use it. Then apart from that, you have to use the software for controller and input output devices. Some of the optional accessories, like some cases you may need a camera also attached in the end effector or some of the parts to monitor. Sensors may be activated in order to suppose to avoid the human interference. To check it like something like a extra check they can you can keep a optional accessories. These are all important things for the robotics and also the classification of the robotics. So based on different power source, we can divide into different types. So basically, what we are using here is like mostly electrical kind of power source. People will use it, right? Like mostly for industrial robotics and all, we will use the AC current. Basically, AC will withstand this large capacity industrial robot. That's why we will go with the AC. Mostly it is with the synchronous with the servo motors. But some cases people will use the DC also. DC case, there are two types. Again, the brushless DC or brushed gear motors, steppers. This can operate. So this will be basically used in the underwater or mobile application. There under we will use the DC. In case of hydraulic, mostly very large capacity robots, they will use the hydraulic. Again, if you are using hydraulic, it may make some kind of, because fluids we are using, so it may create some noise because of the pressure. It may create some noise, or leakage problem is there, and also some of the fluids are fire hazardous. Maintenance also we have to do frequently. These are all disadvantages. Again, if you go for pneumatic, again we can use it for very high speed robots. We can use this kind of compressibility of the gas or air. We can use it. The problem is we cannot get precision like a hydraulic. Lack of precision and drifting also sometimes possible. So we have to be very careful in the maintenance. Okay. Also, apart from this hydraulic and pneumatic, you can use non-conventional sources also. Like you can use nuclear power or the solar. Solar robotics also nowadays very popular. So you can use those things. Okay. So also based on this workspace geometry, also you can make it into different types. So for example, I can divide into Cartesian, uh, Cartesian robot, or Cartesian means nothing but it is here basically the linear activators. Here it has the three linear activators, like x-axis will move in linear, y-axis, z-axis. So basically it is a prismatic movement. That's why it is called it like a 3 pp is there, like Cartesian means ppb. So mainly this is used in the heavy loads because it is very simple to control and easy to program also. Second one is the suppose the here the workspaces look like a cylindrical. That's why it is called like a cylindrical robot. Here only the x-axis is fixed here. Like for example, the base is fixed, so it can not fixed. Basically, it is not a linear movement. It can rotate, and also the y-axis can move and the z-axis can move. That's why one revolute, because here we are using one rotary activator and two linear activator. That's why it is one revolute and two prismatic. That's why RPP. It is called it like RPP. So in that case, we can give you a more large payload, and it is a very rigid structure also. So third case is that we can use it for a very large range because it is a spherical kind of workspace. You will get it. For example, here that there are two revolute here, like because X and Y. Here it is kind of revolute or rotary activators here. The Z-axis only have linear activator. In third case, and all the joints are like a kind of rotary activators, like articulated arm. That is called it like triple R. So this is basically most common in industry. So you can get a 6 degree of freedom basically. So in this case, okay. So for example, in case of Cartesian, we will get a rectangular workspace. That's why it is called it like a rectangular workspace robot or rectangular gantry. It is called it like this. So it has three linear joints that position the end effector. So in the end effector, it may have some additional revolute joint. So you can control the orientation. For example, the coordinated CMM machine, you may know it. Like if you're mechanical people, you may know about this CMM coordinate measuring machine, inspection machine, or laser cutting, pick and place. These are all these application you can keep this robot. Okay. So next is the cylindrical robot. Cylindrical robot, already I told it is having these one rotary and two prismatic. That's why it is called it like R2P or RPP. It is given like this. Basically, two linear joints that position the end effectors and one additional revolute joint. It is basically it is controlling a orientation. Okay. So basically, you can find application in the hotel industry like tool loaders there and all. You can find some application. Okay. Spherical robot, again, mostly it has two rotary joints and one prismatic joint. You may have additional one revolute joint in the end effector. You can keep this holder. Okay. But the thing is that it is basically it lacks the vertical axis movement. Okay. Only it can be act as a tool. You can load it, or specific pick and place robot. You can basically you can use it. Like basically the first the Unimate what they made it, that is spherical robot. Okay. So next is the articulate robot, that is called like a 6R, because 6 revolute operations you can get it here. So normally you will get a 6 rotary or combination with prismatic joint also it is possible in the end effector. Okay, so almost most of the industries are they are using this because we can use it for multiple operations like welding, painting, all these collaborative task assembly can be performed with this particular robot. Okay, mostly this is preferred. Again, with respect to 3D freedom, also you can say it like it's a planar or spatial. Planar means it may have 2 degree of freedom. Spatial means three degree of freedom or rotating robot. Or 6 degree of freedom means it has it has translation or three rotation. It has like this way. Okay. So also based on kinematic structure, also we can say it like it can be a open loop or closed loop. Okay. So open loop means whatever I told this industrial serial robot, like whatever I showed in the first example, that is the industrial serial robot. The closed loop have kind of parallel structure. Like you see the second case. So here, this is called it like a parallel structure. Okay, like it is having a like top having the kind of like parallel like 6 actuators are here, 6 links are here. So that will coordinate the motions are coordinate with that. So it will maintain that base of that particular component. Okay, for example, maybe I can show the video. Maybe you may get some idea. Um, sorry. Mm. Sorry. Yeah. So here you can see that. So what is this serial robot? See this here, the axis is moving parallelly. So that's why it is called like a parallel robot. Okay. So hope you got the idea about it. Okay. So again, in hybrid case, basically it is a kind of tree type system. Okay. So these are all based on the kinematic structures we can classify it. Also based on movement also we can say that it is a fixed robot. So robot means it may not like some of the robots can be like fixed in a certain place also like there is no movement involved in the robot also it is called like a robot. Okay. So some cases mostly the mobile robot means it might be have wheeled or omni wheels like this. So omni wheel these are all mainly used in this carriage system or here we can find it in the space application. Okay. Third one is the swimming robot or underwater robots, or it can be flying also. The aerial robot can fly also. So based on the movement, we can again classify it. So based on the application again, whether it is industrial or domestic application, so we can make it in this way. Okay. So suppose for example, already I told the serial robots are mostly used in the industry, like because it is very easy to program also, and also very easy to balance the heavy load. Like suppose the payload, we can easily balance it based on the programming because of the Cartesian translation. It is very easy to control and point to point wherever this. The point-to-point control is there. It is very easily. That's trajectory will work. Like okay. Also, the giant space trajectory also, in case only the end effector can rotate. In that case, so basically it can create a circular arc in the space. So easily it can estimate the tool path and then programming based on this programming skill. So we can easily this configuring specific workspaces. Okay, that basically restrict the robot entering into the probable area of collision with the surrounding object, or so it can be applicable for the Cartesian motion basically. So basically it will passes through the program path, passes through this robotics singularity. So in that way you can avoid that interference. Again, a parallel robot, already I told about this like variant. Basically it is called like a delta robot. This also mainly used in 3D printing. You can see that some of the medical application, because it has 3 degree of parallel robot, whatever you see in this particular video. uh, that is called like a Jamanov configuration, like uh, because it is extremely fast and precise, and also the kinematic or dynamic solution, also here you will get a workspace singularities exist. So mostly all the capabilities whatever the serial robot can able to do it, it can do it. But the thing is that relatively it is having a very small workspace. That is the main disadvantage. Okay, so now I hope you could able to understand about little bit about the basics of robots and classification of robots, and what is the usage of this degree of freedom, and what is parallel robot, or what is serial robot. Those idea you may get it. Now I am just going into the automation again. uh, when I move to the automation, what I'm going to do is I'm going to start with the automation in manufacturing. Okay, then we will come to the we will integrate the both automation and robotics. Okay, before going into that, just I will tell about what is the general meaning of automation in industry, or automation in production. Then only we can understand the about this integrating both automation and robotics. Okay, I hope if I gave this idea about this automation in manufacturing or production, certainly easily you can understand the integration of how to integrate this both. You may get some idea. Okay, I hope you may know about the production system, right? Like so production system, why we need it? We need to produce the any product. We need a production system, right? Like suppose, I hope you may know about this. All may know about this diagram. Like it will start with the demand, and then based on the customer feedback, we have to get the raw material, from the raw material to the product what you are manufacturing. That is basically it is called like a production system. Okay, basically if you take this system, it is having a collection of workers, means people, equipment, and what are all the procedures to be organized to the perform the different kind of manufacturing operations of a company. That is basically it is called like a production system. Okay, so here basically it has two components. One is facilities and manufacturing support system. Facilities means suppose if you want to create one raw material to product, so what are all these facilities are needed to reshape this particular raw material into particular shape. Okay, suppose these are all the facilities are certainly needed. Suppose if you take any factory or industry, they need a workspace, production facility, material handling equipment, and also we need to do inspection, right? Like suppose, okay, production facility means suppose you are manufacturing some kind of screw. You have to make some screw out of it, then you have to make a thread making machine. So for that we need a lathe. At least you need a lathe to make this thread. Then after thread it will come out from the system. It will fall on the some conveyor, or some material handling package it will come. So the material handling equipment is needed in that time. Again, the inspection we have to do each and every part. You have to inspect whether it has having any defect, or it will fix with the bolt and nut and all everything. It will exactly it will fix or not. We need to understand it. Okay, so also uh, when you go for very big industry, again nowadays the computer systems are very essential. All parts are this, all information is integrated with this computer system. Also the plan layout is very important. The way how the equipment is placed. When you go for big industry means, So it can be very like small scale to very high scale industry. But so if you are going for very big scale industry, then you have to consider about how the equipments are placed, and logical grouping of equipment, and how the workers are divided. So these are all very important. Okay. So for example, if you come to the facilities, so basically it include the factory, production machines, tooling, material handling equipment, inspection equipment, and controllers that control the manufacturing operations. Okay. So suppose if you go for high scale industry, then plan layout also very prime importance. That involves how physically the equipments are arranged in the factory, because that also will play important role in the manufacturing process. Okay. uh, so this is basically the how the equipments are organized. That is called it like working cell, work cell. Basically we'll call it like this. For example, already I told, like suppose you may start with the single production machine, means very small scale, means it may have only one machine. So you can do the product out of it. Like for example, the paper cup can be produced by only one single machine. Plastic chair, only one single mold, you can do it. Okay. Again, if you need a collection of machine, then the production line will come into the play. Then once there are several parts if you are doing, then you need to do the assembly also. For example, mobile phones are automotive. If you take it as n number of parts, right, like billions of parts, like if you take any small car, it may have so many components it has. So we need assembly line. Then so in that case, uh, so not only so only human cannot support it, like also we need a kind of worker machine systems are also will play a very important role. So suppose manual work system means only the human will participate in that particular operation, means one or two workers will perform the operation to to with the aid of the power tools. For example, here, for example, I'm shown here how they are doing. They may use some kind of hand tools. For example, here they are removing this screw, or they are assembling the screw by using this compressed air or something like power tool. They are using screw, they are using, and they are just they are doing the assembly manually. Okay. Or some cases you may need both interaction, like worker machine system. For example, in case of worker machine system, here only the machine tool will be operated by the any of the like case of a machinist. For example, a lathe is there, so you can, by using the lathe, you can fabricate the any kind of desired product out of it. So for that, he need to be a skilled labor. Okay, like kind of he need to be a machinist. Then only he can operate this lathe, and he can perform the operator. He can perform these operations. Again, if you go for welding, he need to be a fitter. Then only he can operate this arc welding. So here the worker machine system is really needed here. Okay, that's what I'm trying to say. So here the human will work on this powered equipment. There basically we won't work on any power tool, like only hand tools they will use it. So in this case, the power tool they are using it, and in the production they are doing it. Okay. But in case of third case, this is a two cases. Then next case is the mostly it is completely automated. Okay. So without any human interface, like a human worker, without any direct participation, so you can perform the operation. Like for example, you can just monitor it, like after each process, that is or one some portion of the work cycle you can perform it. That is called like a semi-automatic, means certain operation it can perform. For next operation, the human should dismantle it, and then they have to keep it in the other operation. Then it is called like a semi-automated. Okay. If it is fully automated, means fully extended period without any human attention. If it is performing, then it is called like the automated system. Okay. So automated means in this process, the machine without any direct participation. So you are giving a some kind of programming. You are doing it. The control system will control the each operation. Like for example, here I told about this engine lathe. instead of engine lathe, there the human intervention is like we have to keep the tool at the correct position, and tool and for the raw material we have to make a correct force and direction we have to do it, then only it will make a desired shape. So here by the programming itself, the robot will select the tool and it will place it in a desired orientation such a way that it will remove the material and then it will come to the final shape. Okay, so without any human participation, it will do the work. Okay, it will run on the automatic cycle. That's what I try to say. That is called like a fully automated system. Okay, so that's what here you can see that conveyor, how this things are moving here, like fully it is carried out by the machine without any direct participation. That is called like a automation. So why automation is very important means, already I told about it is mainly it is plays a very important role in the production life cycle. So for example, we will take a our Maruti 800 car. So it is up to 2014 the production is there, right? Like it started in 1980s, like almost 40 years it ruled the industry, like 4 decades it rules the industry. Also if you take the Ambassador car, it is 1958 to 2014. This is also almost more than 50 years, like 5 decades it is came to that like in the market. So usually this the product life cycle will go like this, like it will go certain growth and maturity, then it will decline. But if you take the nowadays any kind of new car, like if you take any for example we will take any Tata car, like every 6 months, or even Maruti Suzuki also we will take every 6 months they are come up with the new models and keep on their adding the features. So that is then each of the brand is really now it has very less short span. The life of the product is very short span. And also, for example, if you take the mobile, like initially we used this Nokia mobile is very popular nowadays. In market, variety of models are there. Again, if you take the each model within 2 months, 3 months, you will get an update. Like every time the product is keep on changing, and then the product life cycle is really very short nowadays. In order to make it that challenging that environment, to cope up with that, we need a automation in manufacturing. Okay, that's what I try to say. Like suppose the customer demand nowadays is very variety. They need a multiple operations function, EC in operations. Okay, to come every manufacturer now to survive in the market or export, or they want to become a leader in the manufacturing, means they have to produce this less lead time in the manufacture of the product. Then only they can survive or compete in the market. So for that we need a automation in manufacturing or assembly, effective and quick communication. This is the really very challenges involved in the automation. Now in automation, mostly I will talk about only the facilities and uh, um, workplace, but not only that, this also the manufacturing system, this also involved, like what I'm trying to say is sorry, I'm just going manufacturing support system also really very important for the system for the production. So manufacturing support system means this is the basically this design and manufacturing process is basically it is called like a support system. Like for example, again it will start with the marketing, like based on the customer need, you have to do a design specification, and based on the collecting information you have to do a feasibility study, then prototype you have to make it. After prototype you have to analyze the design and optimize. Then we have to do some kind of documentation like CAD and CAE, means it is called like SIM, computer integrated manufacturing. We have to do it like based on that it will generate the process planning. Then again it will come to the production. Again production basically it involves the all the facilities. Then you have to give the production quality control. You have to do the inspection. Then it will go for a shipping. So like this always this also involves like the product design, not only facilities, manufacturing support system also it has the very important role. So facilities means people those who are working in the factory, like factory layout or manufacturing system. Basically, it is called like a blue collar job. Those who are working in the manufacturing support system, they will involve in design or business functions or manufacturing control. That is called like white collar job, basically. Okay. So now if you come to the automation, there are three types of automation is there. One is call it like fixed automation. In case of fixed automation, they will do the one type of product. Okay. It means it is fixed. The product is fixed. Then you can make it like a n number of products you can do it. Like suppose you want to make a screw, then same screw if you want to make it, then it is like you can make product quantity any number you can make it. Okay. Again, the programmable automation means you have to change according to your different uh, shape of the product. Like for example, one product have screw also, some kind of drill is there, some kind of milling operation, some kind of edges are cornered. Then we need a program for that. Then automatically the programmable control that will do the automation. So in that case, we cannot make a product quantity can be very high, so it will be like very less quantity you can make it. Again, in between these both, it will be like call it like flexible automation. Like you can make a sequence of operation. Based on that, you can do some kind of complicated object. That is anyway, in the future slide I will explain about what is flexible automation. uh, uh, so uh, so what I'm trying to say is there are two levels. uh, Basically this computerized manufacturing support system also, it can reduce the effort of human effort. It can automatically it can do the product design or planning. That is basically it is called it like a computer integrated manufacturing. That's what I told. Like by using this CAD software, we will do a design, and CAM will produce this machine. Like it will machine language. It will convert into machine languages. Then it can perform the operation. So basically, the application of automation is to increase the productivity, labor productivity, and also reduce the cost, labor shortage, and also eliminate the manual and clerical tasks. So that is a thing. Then worker safety and product quality, reduce the manufacturing lead time. This is the main important points in the automation in industry. Okay. In case of suppose if you go for the manual thing is task is too technologically too difficult to automate also, then you may go for worker like okay. Also it may need reduce the risk of product failure, lack of capital. These are all certain certain advantages. Suppose if you come to the automation principle, so it may not be a direct answer always. The principle and strategies may not be answer, but these strategies are very important. Okay, like when you are handling the automation in industry, these principles are you have to keep in mind. So one is the USA principle, and automation and process involvement strategies, automation migration strategy. So USA means it is not anything. Not in the meaning is not USA. It's not related to United States. Basically, it is like understand the U means it is understanding the existing process. Then based on the existing process, we have to simplify the process. Then we have to see wherever we can automate the process to simplify the process. That is called it like a USA principle. Okay. So second is the already I told about the strategies. It has some 10 strategies. So first always it will start from the operations, like what how we can different operation we can perform, like combined or simultaneously or integration of operation. So these are all these strategies. First we have to do it. Then we have to increase the flexibility. Then after flexibility, then how to handle the material and how to store the material we have to see. Then we have to do the inspection. Okay, that is online or offline. Online inspection we have to do it. Then we can optimize automation in the process control and optimization. Finally, we can implement for plant operation control, then come to the sim. Okay, these are all 10 strategies. They are uh, automation strategy they are telling for the process automation. Okay, so migration strategy means so suppose if you are uh, producing a very very small amount of product, then we can go for manual production, like because manual always it need a very low cost tooling. Phase two is something like in between this automation and manual, like it may have some single automated cells with manual handling of product between the workstation, like maybe some of the operation you can automate, and some operation material handling you can do it with the human or like people. So in case of automated integrated production, it involves the multi-station automated system. Fully it is automated material handling between the stations. Like for example, so you see here like how this based on this product demand, we can any three types of production you can do it. Like suppose manual production, you need only one station cells. But in case of automated integrated, we need a connected stations, many stations, and also the material handling also should be happen in the like here it is conveyor, it is happening, right? Like that's why it is automated transfer of working units are happening here. In phase two, if you see, we are doing manually, we are transferring to the units, okay, working units. So basically, so what we are talking about is the automated assembly lines, okay. Um, so basically, so suppose now up to now I am talking about production line. Now we will talk about assembly line. There is not much difference, because the major difference, if you take only the automated part feeding mechanism, you have to take it in the control. That is missing part in the production line, okay. Part feeding and how the mechanism, the part feeding mechanism will happen. So here if you see the assembly line, so it can be a rotary, or all the components can be added in one station. So it can go in like different arrangement. Here they shown it for the assembly here, okay, automated assembly here. So always already I told the feed mechanism is the one of the thing is missing as compared to the production line. So for example, here we have to deliver it to the assembly worker from the base part. Suppose here the base part is the yellow one, so it has to transfer to the this red one is inside this red cap. It has to keep it. So basically, this is the assembly worker. This is the part worker. Okay, base part. So basically, it can be just attaching here. So how to feed it, that is the thing. Okay. So for example, here they are using this feeder mechanism. Mainly it is contains the two different types of parts. Like one is copper and parts feeder. Okay, copper basically like it is a large. This is the basically it is copper. It is okay. Copper. Basically, it contains the what are all the parts to be delivered, and parts feeder will remove the part from the copper and deliver to the assembly worker. Means here this parts feeder, like how it is assembled in certain way, and then it is going in certain orientation. Okay, that is also very important. Okay, selector and orientation, orienter. That is these elements are very important, because for the assembly worker we need all these components should be assembled in a proper orientation. Otherwise, it is very difficult to do the assembly, right? So suppose, for example, what I'm trying to say here, the cap is there. The cap should be upfront. It should be keep it in the upfront. Suppose if it is in the other types of orientation, means this wiper blade will just it will remove this like cup shaped part, like this part will be removed, then it will fall into the copper itself. Then only once if it is arranged properly, then only it will go to the assembly line, kind of assembly cell it will go, workstation it will move. So that is the thing. Okay, again next is the it has to go to the feed track. Once the part is basically if it is properly oriented, then it will go to the assembly head. There the purpose of feed track is to, it will act as a buffer. Basically, it will provide the certain how much distance between the parts feeder and assembly head. So like a buffer, it will act, and also based on the gravity also it can operate, or you can give a push and just given some pressure like powered also, based on that it can work. So for example, if you see here the feed track here, basically here it is a rotary table. The feed track basically keep on it is moving, and basically here they are using the timing. Okay. So suppose for example, if you see here second diagram and all, it is a pick and place device. Here basically they will apply some pressure, then they will take out this part and they will keep it in the assembly work cell. So here basically it will act. Third one if you see here, a rotary indexing table. So here the cross section is given here. So based on the gravity, the part will come and place in the certain place. Okay. So like this way, you have to automate the assembly line. So for example, already I told copper and feed track is really plays important role. From the copper, all the parts will come. Whether if it is selector and orienter, that will keep the parts in the certain orientation. Suppose if it is not oriented properly, then all rejected part will be go inside back into the copper. Again, only the arranged part only will come to the feed track, and then it will come to the escape point, and then it will place it in the certain work area, like where assembly will happen. Okay. So like this way. So for example, these are all certain automated assembly lines examples. For example, ball bearing, point pens, electrical plugs, fuel injectors, gearboxes. So these are all can be made by the automated assembly lines. Okay. So mostly this uh, serial assembly line, we will use it in the industrial robots. Okay. So this kind of next automation is the group technology and flexible manufacturing. This system, these are all the advanced like next level, like kind of. So in this case, so so it will identify the manufacturing. Here philosophy is that the similar parts will be similar kind of operation, or parts can be grouped into together, and then it will take the advantage of their similarity in design or production or manufacturing process. That similarity it will take, and whenever it is needed it will recall it, and then it will implement for the any of the new parts. Okay. So for example, if you are producing a 10,000 different kind of parts, there only suppose 30-40 distinct family groups are following the similar kind of design or production, then it will identify, it will keep it in the buffer. So whenever this kind of similar kind of product is coming, then automatically it will do the operation. Then it will equip the machine cell. Okay. That is basically it is called it like a cellular manufacturing. Okay. So organizing the production equipment into machine cell, that is basically it is called like cellular manufacturing. So basically it can possible to group the part into different families. Okay. So mainly it will rearrange the machine into machine cells. So because of that, we can get a material handling reduced, and process planning we can do. We can reduce the setup time and manufacturing lead time. So also quality improvement also very like we can get a very good collaborate in a group technology cell. Okay. Next is the flexible manufacturing system. So here again it is a advanced form of group technology machine shell, because it has more automated processing stations. Okay. Means it is having a very high end sophisticated CNC machine tools. So because of that, it can anything, it can interconnect automated material handling or storage, that can be controlled by a distributed control system. Okay. So again, when you come to these are all about the automation in industry or manufacturing. A little bit about background about this, you should know about it. That's what I told. Now I'm coming to the uh, automation in control system. Like this also we have to understand little bit. Then only control system also play a very important role in the automation. Okay. So basically, in the manufacturing plant, so it is built around the, it is called it like PLC, like programmable logic controller, or programmable automation controller, PAC or PLC. We call this device as this. Okay. So it is just like a VHE video tape or DVD. Okay. Suppose both VHS video tape or DVD, we can record the TV program, but at the same time, if you are using DVD, means that can be used for the extra, like we can use it for music also, data also, or some other things also can be saved in the DVD. Okay, but videotape only it can record the program. Okay, like that only. Like PLC means it's only designed to control the machinery, but if it is automated control, means it can control the machine control, process, motion. We can use it for, you can explore it for any other application. Okay, the basic component is it has a controller, input output devices, power supply, and programming software that runs in PC. That's it. Okay. In addition to that, it may have some kind of network interface. So mainly this has these three important parts: processor, controller, and CPU. So basically, it stores the control the program or data in its memory. So whenever it needed, it reads the status of the input devices, then execute on the control program. Then it comes in a various physical form. So for example, so suppose input output module. So here basically it is connected to the field device. So that will convert the electrical signal into any input devices, so PLC language, based on that, like machine language, what he can understand, it will convert. Then it will, whatever output coming from the PLC, again it will convert to the electrical signal. Then the output signal can be understood by the any of the solenoid valves or motor starter. You have to start the motor or activate the solenoid valve to perform the other operation, like that. Based on that, it will perform. Okay. So again, input model, there are different types of, like sensors are there. It can convert the different type of electrical signals. Okay. Um, so what control, again, if you come to the control system, there are two types, like discrete and analog. So discrete case, it will only use a single bit to represent the state of the device. In case of analog, it will use the words to represent the state of device. Words to represent the state of device. Like for example, suppose here it will use 0 or 1, like kind of machine language. 0 means switch will be opened, 1 means switch will be closed. So but here it has the certain range, like it can, suppose for example, temperature means temperature can be go from 20 to 100 or minus also. So the analog will say that, like suppose if it is going above 50, means it will switch on the switch will be closed. If it is below 50, then switch will be in the 0 condition, like this. So that is the difference between the discrete and analog difference. Okay, already I told about it. So mostly in the market, if you go to the discrete model, you may get it like 16-bit devices, like 16, you may get it. Okay, 16-bit of memory, even analog also. Again, output model, again it will interface directly to devices, then it will start the motor or light. So based on whatever application, it will give the output. Okay, it will convert them the electrical signal to what the motor can understand or sensor can understand. Based on that, it will operate the output. Okay. So now I'm coming to the automation. So we can use this control system to robots or computers to handle the process without any human interfaces. You can use all this to monitor the or control the production process. It can be any kind of automation, like fixed. Mostly in case of automation in robotics, the fixed automation is used. Even you can use the flexible and programmable also. Uh, so if you want to integrate the robotics in your production line, so we have to identify the automation opportunities first. Then we have to choose the right robot. Like already I told, many different types of robots I told. So we have we have to choose the what is the right robot and automatic system. Then based on that, we have to design and implementation strategy. We have to come out. Then we have to overcome with the all this. What is the cost of this plant and workforce readiness? So everything it will come. Then only it will come to the real world example or case study. So anyway, I will show some case study. What the people did for this BMW and Tesla. Some of the some of the video I will show it in the last. Uh, so also the role of collaborative robot also play a very important role in the modern production line. So collaborative means it's call it like a cobots. Usually they will call it like cobots. So which will work alongside the human workers. Okay, in production environment. So because it has not only automotive industry like electronic food processing. Nowadays, this human robot collaboration is really very essential. So that is called it like a cobot implementation, like what I told that second one, work human and workplace interaction. So next is the people are using this artificial intelligence in robotics. That is the next frontier in manufacturing. Okay, so that will enhance the AI. Basically, the AI will enhance the robotic capabilities like predictive maintenance, adaptive control. Also, we can use artificial intelligence powered robots like quality inspection, smart assembly. For all the cases, we can use a artificial intelligence. So anyway, it is everything involves some of the feature possibilities and challenges also. Okay, so also we have to uh, do the cost benefit analysis also in the production line. That is also very important because how basically in the short term how it is affecting means the initial investment how it is affecting and long term savings like how the increased productivity, how it is lower the labor cost or reduced errors. These are all you have to take in mind. Okay, cost of implementation you have to take in mind. That also play important role. Again, quality control, like robots can be used in this quality control that will improve the consistency in the production line. Basically, how these benefits of like quality control process, like it can be a visual inspection or defect detection. So you can use the machine vision system for do the quality assurance. Okay, so those kind of places how it will how we can improve the consistency. Okay, so nowadays internet of things like iot also, uh, iot and big data, these also mainly used in enhancing the automated production line, because it can enable the real time data collection also. It can do a predictive maintenance and enhance decision making. So these are all the real benefit of the IoT or big data. So nowadays, people are doing it in the automated production line. Uh, okay. So also, so these are all the already three things I discussed. These are all the smart, the era of smart manufacturing and robotics. The collaborative robot. One is the collaboration between human and robots without any barrier or cages. Also it should be a flexible to different adaptable to the different task. Next is the artificial intelligence integration that can lead to a enhanced decision making and flexibility. Also you can use the machine vision system for the quality control and inspection task. Also you can expand to the not only industry like not only the automotive industry, other electronics, food and beverage, pharmaceuticals, consumer goods. So these are all you can implement it. Uh, so also the technologies nowadays, if we come to the industry 4.2, this IoT, advanced robotics, big data is really play a very important role. So nowadays Tesla basically the use of this robotics for precise assembly. We will see it uh, um, certain things I will show you. Also, if you come to the future trends, mainly it is used in the artificial intelligence and deep learning, 5G connectivity. So these are all have some future trends in automation. Okay, uh, fully autonomous factories, also certain kind of challenges in the last slide. So I'm just coming to the last slide. These are all certain challenges in the evolution of the robotics and automation. Like mainly thing is the initial cost and workforce adaptation. Once if it is done, there is certain kind of technical limitation is there. Then you have to think about this little bit about safety and ethical concern. Then these are all the challenges. Okay. So we will see some example now how they improve this production rate and precision. Okay. First, I will show you some 2 minutes video, and then I'll just conclude it with that. You can see that like simple pencil, how they automated. See that like 14 lakh pencil are like so how they are mixing the clay, graphite, and some colors. They are inserted into this milled wood. All are automated process. You can see that like and how they are glued and then made it into the pencil shape. So it is another example like how these ingredients are like they are making it different kind of food product, salad packaging industry. You can see that different salad. Then Tesla car, you can see that like fully automated line. You can see that it is doing this pick and place and then spray. So some of the manufacturing operation it is performing. So all the parts are manufactured and assembled in the same factory. You can see that. So painting, how it is doing this automatic painting. So then also this BMW car also you can see all this articulated robots are how it is involved. Okay. So hope you saw some kind of like where it is used. Like mostly we find it in welding, assembly, inspection, like almost all the areas, right? Like so this is my summary. Actually, based on this feature of manufacturing will be highly automated with robots and human working together in more intelligent and flexible production environment. So this ongoing evolution of automation and robotics, I hope it will continue to drive efficiency, quality, and innovation in manufacturing across the many industries. With this, I will just conclude my talk. Thank you for listening. So, is there any query? Maybe we can go ahead. Yeah.
Thank you, sir. Any questions from participants? Unmute yourself and you can raise the question if any.
I hope you got idea about.
Hello, sir.
Yeah, please.
Myself, Dr. Manish. I did my
Yes, sir.
PhD from IIT Hyderabad.
Yes, sir. Tell me, sir.
Nice to see you here.
Thank
Under
you,
the
sir.
guidance of Dr. Mayan Surya, sir.
Yes, sir. Yes, sir. Thank you. Thank you.
Very nice to see you
Okay.
presenting here.
Okay.
Now I am
Okay.
teaching in CPET.
Okay. Okay. Actually, your voice is breaking. Hello. Hello.
Did my PhD in editing. Sir, I just will you share the slide to all of participants. So it will be helpful
Yeah,
to
yeah,
them.
please. I will share it. Yeah, certainly I will share it. Yeah, no problem.
Thank you, sir.
Yeah, thank you. Anyway, I think coordinator they can share the slides. I just shared my slides with them. They can send it to all. I think. Hope you may get some idea about introduction about robots and automation in industry. Then some of the case study I may discuss little bit. Tomorrow I will mostly talk about research related talk I will give. Okay.
Any questions?
Excuse me, sir.
Yeah, please.
Sir, what are the challenges or faced when integrating automation into existing productions, sir?
So that's what like we have to see about what is cost of this initial cost. Mostly they will see about whether this workforce adaptation they will see like they have to reskill the worker or the machines, right? Like they have to purchase the new equipment, how to manage the different type of systems. There are technical limitation will be there, and also workforce adaptation also you have to see means we have to reskill the workers. Then the cost also you have to see. Then finally with that integration, it has to be a safe collaboration, like safety and ethical issues also you have to take care. So that is the main things, main challenges in this existing things.
Okay, sir. Thank you, sir. Thank
Yeah,
you, sir.
yeah.
Any other?
Hello, sir. This is Venkatesh. Hello.
Yes, please. Yeah.
Hello. Sir, how cobots are preferred? How much they are into the industries? Are they cost effective, sir? Still cobots, collaborative robots.
Yeah. So cobots, why we are going for cobots means mainly for this like flexible and adaptable to different tasks. Actually, like flexible manufacturing. Mainly people are nowadays looking for these cobots.
Okay, sir.
Yeah.
How much it is cost effective compared to?
Compared to that full
Cost.
automation, the cost might be you can reduce too much, like maybe 30% or 40% it is reduced. So what I
Using
saw
cobots.
from this different study. So
Okay.
it case to case it will differ, but mostly it will reduce the cost certainly. Yeah.
Okay.
Yeah.
Thank you.
Yeah. Thank you.
Any other questions?
Hi, sir. I am Prabhu.
Yes. Yeah. Please.
So you're talking about an automation. What is
Yes.
the future about the manpower? When we are going for an automation, the manpower slightly decreases down.
Yeah. Anyway, it will affect the manpower, but again, I told right, like we have to be compromise certain things. Uh, even like that's what I told about this. We have to coexist means with this cobots, like we have to collaborate with this human and robots, then only you can speed up this productivity. Like nowadays all customer need is like keep on if you see any product life, the product life is very reduced, right? Already I told about this example, like how this product life is totally it is reduced. So in that customer taste, if you want to adapt, then we have to go for certainly you must go for this collaborative robots. Anyway, it will little bit it will reduce the manpower, but at the same time we have to collaborate with that. Yeah.
So any kind of survey has been taken?
What any?
What kind of survey?
I don't know. Maybe it might be there. Certainly, it might be there. So we have to see some literature. Certainly, people did some kind of review. They may did it already. Yeah.
Okay, thank you.
Yeah. Thank you. Yeah. So thank you. Then.
Thank you. Thank you, sir. Thank you, sir. Good evening to everyone. It is a great honor to thank Dr. Dan Satyaraj sir on behalf of our management and institution for his immediate acceptance to be a resource person. Dr. Dan Satyaraj sir has shared valuable insight in robots with industrial serial and parallel operations with video examples. And then production line integrations, automation in production lines, and etc. A big thank to our beloved resource person. Thank you, sir.
Thank you, sir. Yeah, thank you very much.
For their enthusiasm, which made the session even more meaningful. Once again, thank you all.
Yeah, okay, we can meet again tomorrow, hopefully. So,
We'll
thank you,
join
thank you.
6 p.m. for the third session. Thank you.
Thank you.
The feedback link is available in the chat box. All the participants are kindly requested to fill the feedback link. Thank you. Thank you, sir.
Thank you, sir. Thank you very much. Yeah.